Uh-oh, Stream Deck isn't working. Something weird happened. I think my internet went down last night. And my regular computer tells me that I don't have internet. It's even though it's connected and running stuff, which is really weird. I think maybe well, first of all, the Stream Deck isn't working, so let's get that back up. That's a vital component. Oh, it's not even running. Need to run the software for it. Dude, Stream Deck. There we go. Start that up, let that start. I've got all these automations in Stream Deck that make this stream happen, so I need them. There she is. So that means I should be able to get start soon on here. Set up. Oh, as soon as it actually starts working. There we go. Start soon, like that. There we go. My camera's already calibrated because I didn't close OBS on this machine. My other machine is the one that I think updated and restarted. You can have two computers in the same room and they'll update at different intervals. Windows is supremely frustrating. All right, what else do I need? Well, I need to kick this hangover. That's what I need to do. And I haven't published anything to YouTube in a little bit. I apologize. This technically counts as publishing, right? The live streaming. So I don't know what the algorithm's going to do. It's going to dump my ass is what's going to happen. Toggle the lights on. All right, so all my lights still work. That's kind of rare. They fight over IP addresses. They're all fixed IP addresses, but when my lights go out, or when the internet blips and everybody needs to be reassigned all of their addresses, for some reason the Tasmota devices just don't come back properly sometimes. And I have to like flip the breaker for a couple of them that I can't get to, like the track lights. Can't get to them. Gotta flip the breaker to restart them. I don't know what that is. Maybe it's a bug. Maybe I need to update firmware everywhere. All right, so we got our chat room there. Let's see. I didn't hit my web pages button, so I need to get the YouTube channel. Actually, I should just hit the web pages button here. Let's just do that. Boop. It's so much easier to open 5 pages this way. There's YouTube. Click on that. And then mute myself. Oh, I'm already muted. Pop out this chat. Where's the control to do that? There it is. Pop out chat. I wish YouTube had a consistent address for the popped out chat, but the URL changes. Twitch has a consistent address because my chat is actually an IRC channel. So it's very nice and easy for me to automate around that. How's it going? I hungover. I'm not happy to have a hangover. I just have one. And it is hot out here. I've got to do all the domestics right now. So I threw dinner in the washing machine. I fed the garden and I watered the dog. I think I got that right. Yeah, did dog walks and watering the entire garden, and it sucked being outside today. Yeah, I do not envy anybody who has to be outside today. Sorry, I'm closing windows. That's why I'm looking into the distance. We're going to do some basic reverse engineering today. So it's just going to be pen and paper with the images that are up on the computer, because that's about the level that I can handle right now. And we'll compare it to the working schematic of the 303 and put to bed whether or not the chip that I put in there is the correct chip. That's really important to me, because currently we can trace on Dave's M303, we can trace the origin of the actual signal that this thing produces all the way to the chip that is responsible for the H or whatever the hell filter it is. The transistor ladder filter. Transistor ladder filter is baffling to me. There's also diode ladder filters. Excuse me, burping a calzone. I watched the Moritz Klein video on transistor or diode ladder filters. I don't understand it still. I don't know what's going on. So, speaking of Moritz, through Erica Synths, Moritz Klein just released a new module, and it is a module building module. So it's got the regulated power on it, and it's got a breadboard where you can build whatever electronics you want in order to do modular synthesizer stuff, which I think is pretty cool because it has all of the signals that you need, all the triggers and stuff like that. So you risk breaking things if you put in the wrong chip. This is already broken. It's already been written off as dead. Although Dave will be getting it back, and he will be getting it back in working condition. But if it's already dead and I put the wrong chip in it and break it further, that's it's just something that happens. And unfortunately, I plugged this in backwards. Like the two headers here you can plug it in upside down, and something got cooked, I think. Is a transistor ladder filter using the transistors as some sort of controlled variable capacitor, or is it doing something else? It's using it as diodes. They're diodes. Anyone watching on YouTube or not watching live does not hear the music that's going on. I'm playing one of my favorite mixes of unironic but ironically good music, which is all corporate rock. It's all crappy corporate rock. Just easy listening. It's hilarious. I love this mix. But I also like the mix, like unironically. It's weird. Where do you get the pliers with the orange ring on either handle? These guys? I got these a long time ago. What are these? The HDX is written on it. I got them as a set of 3, and I think I got them from a home improvement store. But I've had these for a long time. I just like the wide nose on this. There's 2 more of these. That one's a needle nose, and the other one's, I don't know, something else. But I don't know what happened to them, because I've had these for so long. I've worked on cars with them and stuff like that. But they were just a set of small pliers, and they seem to be handling things decently. Just these handles will slip off eventually. But that spring has been everlasting. The spring hasn't gotten destroyed or stretched or anything, and it still happens to work. But if I'm really using these, this handle will move around all over the place, and it gets really annoying. What's up, Bovanet? Bum, 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 bum. Oh boy, yeah, we're in for it today. I gotta go through those images. I gotta get my notebook over here. We'll get a big marker or pen. Seen similar ones come with Prusa printers. That's odd. No, these were some kind of a special thing. HDX. They're just small pliers. There's a set of 3. These are, of course, Nip-X, which are coveted. These are very nice. I got this because I use them a lot. I use flush cutters quite a bit. Sometimes I use them as flush cutters. And now they're gone. Now they're gone, never to be seen. I kept trying to print Benchy, and it keeps failing. I think I need to re-zero the 3D printer because, boy, I don't know nothing about resin printing, and the whole point of getting the resin printer was so that I could learn a little bit more about what it involves and you know, what goes into it. When things work, holy crap, is resin printing crazy. But when it doesn't, needle nose and flush cutters, I've not seen. The mini linemans. Is that what that style is? The snub nose style? Is that a lineman's? Yeah, so resin printing sucks. It's very useful, and it's going to be very useful around here. I assume in the future. I think I need to move it out of here. I need to move this tent into the other room, and I need to figure that out. That's going to be a tough one. I need to clear off a shelf that has a bunch of spillover stuff on it, so it shouldn't be too hard to find a place for everything. Is there a delay in? No, there's no delay. Okay, it's just weird. Weird. This computer has been on for quite a while. I should probably restart it at some point. Oh, and I also need to look at. Ooh, yeah, it's gonna need some water. Bubbles. I guess the water system kind of evaporates through the silicone rubber hose. There's like a lag. I keep seeing these weird lags. What's going on here? Oh, is it my hard drive? No, I cleared out the directory. That should be fine. I need to do uploads. I've taken a couple days off. I just couldn't do it. I just couldn't do it. I needed the mental clarity of not having to do uploads for a minute. And now I have truly lapsed. Wednesday, no content went up from me. That's a big faux pas with YouTube. But it's not like I'm making money off of anything, right? It's just, I just, being in favor of the algorithm and getting suggested to people has already happened. That already happened and it's passed. And I got maybe like four more people watching, which is great. There probably are more YouTube and on-demand style watchers of the show now. That's cool. That's all cool. But it wasn't like an amazing, momentous amount of sudden engagement, you know? So it's not really that worth pursuing. Wasn't sure to call them, and they're similar to lineman's pliers. Yeah, I would think lineman's pliers are like a specific thing, right? Let's look it up. Let's look it up. Just like gunk on the desk that's interfering with the mouse. I hate that. Let's see. Web page. Activate. Plier types. Types of pliers. 15 list top 10 pliers. Wire twisting pliers. Those are using like racing and stuff. Hose clamp. Combination. Wire strippers. Round nose. Needle nose. Circle clip. Circlip. Side cutter. Flat nose. Ah, so I did have the right term according to this website. What's up, Sienna Gears? Hose combination. Wait, there's two combination. Wait a minute. Those are the same name. Yeah, I think it's a little bit more simplistic. I don't know if linesman. There may be specific linesman pliers. Linesman pliers. No, you're right. They are very similar to them. I don't know who made the miniature pliers that I'm using. I don't know. They've been around longer than a lot of stuff. Longer than maybe some of the people who are watching have been alive, even. I just clicked off of Rabaz's stream and he was cursing about taxes. So, you know, same shit, different day. Oh, do we have? Yeah, we do have YouTube chat up here. Yeah, that's all here. I bought a pair of these large slip joint pliers. Slip joint pliers. I've been tempted to get those hose handling pliers, but I don't really need them all that much. Where's my browser? Slip joint? Slip a joint. Oh, that's the ones with the circular thing for like pipes. Twin grip slip joint. Well, the Nipex ones are weird, but generally that's just the plumbing plier that you find all over the place. And the joint in the middle slips so that you can get it to leverage properly. Not quite channel locks. Channel locks are a little different from that. Yeah, the ones where the plier at the tip goes kind of like around and it'll clamp like this, but it's like that looks really cool and it looks really useful for when you're messing with hoses to be able to like grab one properly. But then again, like I just grab the hose, like you know, you just grab the hose, you just do it yourself. You don't need a tool. But you know, maybe if you're getting into like a cooling system that was on a car that was just running. You'd want some isolation and be able to just like grab the hose and pluck it and get it back in too in a tight spot. And get it back in too. I should make a manual gate thing. Basically, I need that module testing and module building thing that Moritz Klein just released. But it's $200. 200 euro bucks too, so it's probably worth. It's probably more than just 200 bucks because it's in euro, and I think the euro is stronger than the dollar right now, right? So it'll be like 150 or something. Or, no, sorry, 250. It's like too expensive for what it is. Too expensive for what it is. It's just it would be nice to have somebody else do the work of making all the support stuff that I would need in order to test modules. But I should put together like a module testing module. There's a mutable instruments design that I could pretty much just gank and use. That'd be pretty cool to have its own little O-scope and stuff. It's so much effort, and I just want to take a nap. I don't know how long I'm going to be streaming today. I'm kind of beat. I did all of my laundry. I did the grocery shopping. I got all kinds of stuff. I got Willow a toy. She got one of those lamb chops toys that she's able to eviscerate in about 10 minutes. And boy, howdy did she. And I watered the garden, and I did all that stuff, and I am fucking exhausted. I'm exhausted. It's like mega hot out, so it's just one of those lazy days. But yeah, if we can get into this and we can get a lot done, hopefully it won't be too taxing to get through. This is kind of like a thing that I can do without my brain, kind of. You're basically, when we do what we're doing today, what we're doing today is pen and paper reverse engineering a schematic from a picture that we've traced all the traces on. So what we'll be able to do is quickly go through and write down, and we already have pretty much a schematic. We're just verifying that the stuff we think is there is in the same structure. That'll get us familiar with all the components that go into this, and we'll be able to get a better understanding of where we need to probe this circuit in order to test whether or not it's functioning properly. And it's not, because it's not outputting, so. But we'll be able to know a little bit more about like the specifics of what we need to do to this thing, and hopefully that'll be the final nail in the coffin for getting this thing working. I'll know, okay, that's broken, let's check this out. You know, we'll be able to get a little bit more focused in. If we had a full schematic from Acid Lab, that would be great, but unfortunately we don't. And if Ben Gizmo shows up, I want to figure out where the hell did he get that PDF? Because that thing was great. If there's more data like that anywhere, I need it desperately. And oh yeah, so I tried to print Benchy. I tried to print Benchy in the chamber over there. I also made a little exhaust fan frame for the window. I need to find a 12-volt power supply for this, but I've got an adapter and everything over there. I just need like a faceplate on there where I can have the plug. But that'll exhaust. I mean, I could have probably gone to Walmart and bought one of those in-window dual fan things for like $10. Here, let's see how much I could have spent in order to do what I wasted so much time on yesterday, putting those two 200mm fans like that. Window fan. $40? Hell nah. $40. By the way, on Tuesday when I finished streaming, I couldn't find Willow. I didn't know what happened to her. I went upstairs, there was no dog. And then I looked upstairs, and there was dog. Dog was in my room on a pile of laundry. I don't know what compelled her. Maybe it's me shouting down here that she doesn't like. She's looking for quiet. But like, she got a good night's sleep and everything, so I don't know why. Dogs sleep like 14 hours a day, don't they? I can't leave your mind. No, get out of my head. So, I mean, I guess I could get something like that for $40, and that would probably do the same job as my stupid 200mm fan rig, and that would free up my 200mm fans. You guys can see, like, the junk is piling up, and I'm starting to get a little self-conscious. I need to do cleanups. I need to go through and clean stuff up, because there's just debris everywhere. And it's not like everything in this picture, except maybe save for the cardboard box, is something where I'm like, I'll need that. I need that to put that aside. I'm going to need that at some point. It is really killing me. I'm starting to fall under the weight of all of the bullshit that I keep around, and it's something that, like, some people don't ever address. Some makers don't address this, and they just have junk piling up constantly. But for me, I need to go through things and weed out all the stuff that I don't need. You know, we can make do with what I have for a lot of different projects, but sometimes I need to just fire the gun and make the purchase of the thing that's a little bit more expensive, that solves a need, instead of building something out of things that I have, because I've squirreled away stuff that'll suit a purpose. I can't do that all the time, and so the junk starts to pile up. I need to go through and weed out all that crap that I'm holding on to hoardingly. It's tough. It's hard to do. You got to get a trash bag, and you have to turn off the part of your brain that likes to think of cool stuff to do with things. It kind of sucks, but yeah, I got to do it. Because I'm starting to spill over. The storage area that's behind that wall over there is crazy populated with stuff that I do not need, including wires. Wires are the big one. Wires. You're like, what if I need a USB-C plug? What if I need two? Why do I have two sitting over there? That shouldn't happen. One of these is actually Nintendo branded, so this one probably goes back to storage. Or into this drawer where there's a bunch of programmers. All night long. Oh, my potato gun is back there too, next to those boxes. You can see a little barrel pointing upwards. That's my potato gun that I built in 1999, I think. It wasn't the 2000s yet. Or maybe it was. It could have been 2001 that I built that potato gun. I mean, I still have it and it's still in, but then again, it ended up in the basement of my parents' place. So when did I build that? It may very well have been, it's an air-powered potato gun, not an explosive potato gun. My friend was the one that would build the explosive ones. He had a huge backyard. I built that thing to do air pressure, and it was air pressure in a PVC container, so it was not a good idea. And I think that I was trying to convert over to using paintball air, but I built a sweet potato gun around that time too. The thing about this one is it actually uses parts from a sniper system. The trigger with the button in it that sets off the big solenoid comes from a Vietnam-era night vision system. It's a night vision scope that would go on top of a sniper rifle, and it had this 20,000 volt infrared illuminator. We had the lens for it, and we were able to put like a car headlight on the back end of it, and you could feel heat on the other side from the infrared. But it has long since gone bad. Whatever they used to manufacture the plastics or whatever have gone opaque. But yeah, there was a giant infrared illuminator that was super high voltage, and it would go on the front of the rifle, and you had a button that would activate the illuminator. So you'd have your trigger, and then the other button up front. So the parts of that ended up being the actual handle for my potato gun, as well as the thing that activates the solenoid. It just had a bunch of 9-volt batteries in it that would set it off. And I haven't brought myself to fully disassemble and throw away everything. I do need to get rid of all that stuff. I was able to send one of those little like McCormick spice canisters from one corner of our 1-acre property to the other. And I broke the fence. I never told anybody I broke the fence, but it smacked the fence and broke it. It was the spice container was filled with stone dust, so it was kind of like a blunt projectile. I should have tried to do a sabot round. It had 2 halves of something with like a heavy dart in the middle. That would have been disastrous. Shoot that into the woods. I'm debating on whether or not I want to start the print again. I need to zero the axis, so I need to put a piece of paper down on the thing and then lower the axis down, and then we can start a print and see if it'll actually succeed. Vibe. What do we? Oh, the music, yeah. The ironic soft rock hits of yesteryear, thanks to 8-Ball of the Space Cowboys doing his yacht rock mixes. It's like wedding music. It's like old person wedding music. Late 90s wedding music. Let's zero this axis. Let me get a print started here. Yeah, I'll put on the respirator. Oh, that's right. Vibe is the bunny emote. Why am I not seeing it? What's going on there? Why am I not seeing the freaking emotes? Hey. What's going on here? Is BTTV deactivated? That might be it. Wait, why do I have SARC emotes? Oh, did somebody give me a SARC? They must have. Well, thank you, whoever that was. Oh, and I've got a Cannibal Jesus, too. Somebody gifted me Cannibal Jesus stuff. Thank you. What's up, Disco House Days? I was in one of those once. Yeah, I don't see Mia either. Like, ah, man, something's messed up. I have a Chrome update that I haven't put in. I'm not going to be able to, like... I'm going to be really confused by all of those emotes. Let's zero in axis here. I've got it all cleaned up and everything. We might as well start print. For this, I'm going to put on the respirator because I'm sick of breathing in these fumes. The particular flavor of this 3D printer is really getting to me. I should probably put this on first. I need a place to put the reservoir, like, to the side. All right, this is going to get scratchy. Maybe not. There we go. Nobody knew who I was until I put on this mask. Where is the Batman? Or, Courier. I can't do that voice. My voice isn't that deep. All right. Oh, I need a piece of paper. Ah, damn it. All right, hold on. I'm going to go get a piece of paper. I don't keep pieces of paper in here. All right, I got to go get a piece of paper. One sec. This sounds like the Access Hollywood theme. All right, so piece of paper on the lens, on the, what do you call it? The LCD. This stinky mofo needs to go somewhere stable. I'll put it over here for, well, actually it's fine right there. And then I've got the axis here. Oh, I need the hex key. Big hex key. Where did that one go? That's not it. You guys see my big hex key? How's my volume with this thing on? Yeah, I guess you guys can hear me. I gotta breathe deep in this thing. My beard, of course, doesn't make it seal quite right. Here it is. Big hex key. So I'm just going to release the bottom of this plate. That one's already loose. So this is the build plate. This lowers into a vat of resin and gets lifted from it. All my benchies have been breaking off though. So the thought is that one should zero things. Oh, looks like there's a little bit of resin on the thing. All right, so put this on. You guys can barely see me. You can barely see what I'm doing, but rest assured, it is what should be done. Tool, set Z to 0. Oh wait, cancel. Manual, back to 0. Now it's going to lower. You guys can't see. That's the only problem with this hood, is that it's hard to see in it. It'd be better if I could 3D print over there, but... Okay, and now what I do is I should push down lightly on the plate and then tighten the 4 bolts. And that should zero us. Tighten the bolts. Tighten, tighten. What direction am I going here? Just basically just resting my hand on top of the plate. Alright, so that should be hard to move, and it is. So I'm going to set my Z up 50 millimeter. Well, probably 100, because then I can fit the reservoir in. All right. Now, I think we're good to go. I want to wipe everything off, because I don't want dust in there. How stinky is it? I don't need the respirator right now. It's not that stinky. Whew, I can turn on this, though. This thing is a little too big. The new fan gets here on Saturday. New fan is here on Saturday, so it'll be a minute until I can actually properly keep fumes away. I want to wipe the bottom of the reservoir because there was a little spot of resin underneath. Whew. Yeah, I know. PPE vibes. All right, let me get a paper towel and I'll get a little bit of alcohol on it, and I'm gonna wipe under the plastic and then wipe. I'll do a dust wipe on the other thing. Actually, here's some alcohol. Whew, that respirator is tough to breathe in. It's kind of really annoying. I'm glad we didn't have to wear those during the pandemic. Masks are so much easier. I do have a bunch of N95 masks, actually, but we're not dealing with dust with this thing. It's organic stuff. So this one has the carbon filters, I think. I think it has carbon filters. You know what? I don't know. Maybe I need to buy some carbon filters. Either way, I don't smell inside of this. GMA 0V. Huh. I don't know. GMA 0V is what's in this. I don't know what that means. All right, so this reservoir is the stinky part. This thing right here. And then I poured it over here, so I need to wipe this corner. Pouring it, unfortunately, involves the stuff dripping down over the side, which can get kind of messy. That's fun. When you wipe it with alcohol, it becomes more clear. All right, so any stray resin has been mopped up there. Let's do a quick dust wipe there. Ow, this thing is digging into the side of my finger. What I need is a way to hang this thing up at an angle so that I can drain it properly into the funnel. But in lieu of that, I shall simply just use this as it is. All right, screw this down. I'm gonna set Z back to 0. Back to 0. It's gonna lower the axis. That should be perfectly oriented. Hopefully. Oh, I hope those haven't hardened. All right, so that's zeroed. I'm gonna dump a bunch of stinky resin into this thing. Blah. Nasty. This stuff is nasty. I'm well below the max fill. I don't know about filling it to the max. I don't think I really need to do that. I don't know how much resin you go through doing this stuff. I've only had one successful print. Put glasses back on. Running this filter means all the fumes are going into the back of the hood. It also means there's a lot of background noise, but we can close this up. And now the stink chamber is complete. I can turn this off. Although when it prints, I think there might be some more fumes, but we'll see if it gets fumey in here. I got a fan right here, so I'll know if anything leaks out. I think now I can start it up again, and I know that it's zeroed since what happened was I cleaned the whole printer and put it all back together. I didn't touch anything on the axis. I don't know, maybe it shifted a little bit, and maybe that's why it wouldn't stick, but from what I see in the print bed is this piece, and then a little bit above that. And so somewhere around, I don't know, like, where's it? Hold on, can I do this from the top? No, I can't. Right click, that's right, right click in order to move around. Why is this doing the layer preview from the wrong side? Should it be from the other side? Weird that it only lets me go from that. Oh, because we're in export. Maybe if we're in prepare, Layout, prepare. It only does it from that side? Oh, there we go. Yeah, it's basically I find this. That's what I find stuck to the printer. Wait, what direction is that in? Hold on a second. No, that's correct. I basically find this little piece in the print, like stuck to the plastic. And then I tried to get another one off of the plastic, and I scratched the plastic up doing that. The plastic's pretty sensitive. So I'm actually going to move this over here. We'll just see how that goes. Without any support. Although it seems like it does need some stuff in order to help it pull up properly. Like a little bit more surface area on it in order to keep it stuck to the bed. In which case, I guess I'll have to add supports, but we'll fail again. I'll try it one more time. So send wirelessly to Elegoo. Send and print. Benchy.goo. That'll do. So yeah, there's all it's like 1,700 layers. Actually, does it tell me how many? Default, 3 hours and 20 minutes. Lift to 48 millimeter. All right, let's see. What are we doing over here? Oh, there they work. So they work in my normal non-popped out chat. It's just when the chat is popped out, it doesn't do it. It doesn't animate them. What up, Keros? How's it going? Strange. Did see, I see you guys, I see all the emotes here. Usually they're animated. I don't know why those stopped. There they go. But in my pop-out window, they're not in there. Just starting out the day, how are you? I've had to do all the domestic stuff already. FEP suction fault. But why would it... No. Yeah, FEP suction. Yeah. So the FEP was too sticky, and there was a bigger surface area on the FEP than there is on the actual bed. All right, it just zeroed itself, so that thing's going to go underway, doing its thing. We won't really be able to hear or see anything from it until it's done, but yeah, all right. I would not wake up today. I don't know when I went to bed. I took the dog upstairs. Or no, she actually fled. She was somewhere I couldn't find her when I went to bed. So got it up and running. Yeah, the last stream we actually had it running. Just none of the prints worked. So I had to clean stuff out, and I just re-zeroed it. And so trying again. The fumes, I don't know, the fumes might be a little too much to keep in here. I might have to clear off a space for it in the other room. Resin printing kind of sucks. It kind of sucks, but, you know, I'm playing with it. Let's see, we'll do that, and then I'll be able to see. I gotta get both of the chats up here just so I don't miss anything. Yeah, we should get to work. Let's get to work. Now that I've started that print, and we'll see if we can like have a decent benchy by the end of it. By all means, it should stick to that material just fine. It's just a spring steel plate that has a little bit of texture to it, so that should help the print stick. So I don't know why it's been pulled off the last couple times. Pretty bad at times, some worse than others, like the ones that stay a bit more rubbery. Yeah, I don't know. You know, that first benchy that I printed great though, so it should all be good. It's just yeah, the FEP sheet was too sticky or something, and by definition it shouldn't be sticky, but here we are. And I have the right side of the FEP facing downwards. Everything else about the printer works. These printers are so simple. not that much to go wrong. All right, anyway, we should get started, so I should get the music out of here. Anybody who's watching this now won't be hearing music because Twitch sucks. Because Twitch sucks. Freaking copywriters suck. Can't have nice things. Anyway, what are we doing today? Well, Dave's synthesizer remains broken. Oh, the smell, yeah. Dave's synthesizer. This thing is still broken. What the heck? What happened? Well, Acid Labs doesn't exactly help you when plugging in power to the module. The standard modular synthesizer plug has to be offset by 2 pins in order for it to plug in properly. And if you get it wrong, it will blow up the module. And so, thanks to Ben Gizmo, some weird connection that I don't know how they got it, but apparently the engineers at Acid Labs had to repair this quite often. Which, like, guys, like put a keyed connector on this thing, or give us a marking, something to tell us what orientation the plug should be in. Anything. But I guess all the modules are made, and they're made without a silk screen, so here we are. Anyway, the point is, these things blew up so much that there was a PDF that was released that gives a listing of the exact parts that you should replace in order to get this thing running again. And had I gotten that PDF sooner, I would not have been probing around on this thing and plugging things in wrong. I accidentally plugged it in wrong. And so I might have done a bunch of damage to this that need not have been done. It was unfortunate that that solution where all of the parts that we need to replace are laid out right in front of us didn't work. I mean, it did work. It did get the oscillator to actually work. We do have volt per note. Well, I have to adjust that back in. That's actually a real pain in the ass to do. But before I do this, I would like to have the rest of the synthesizer working. Point is, it doesn't output anything. We have a wave that we can trace inside of this. We can't really get it out on the other end. So what we need to do is get an idea of what exactly is going on over here. And we can see some of the structures. We can see a bunch of transistors in a ladder configuration. I don't know what broke, and I don't know where to probe, and I don't know what voltage levels are what. We have two pieces of information that we've gathered from this circuit. One is a picture of, that was the last VOD I did. I haven't been doing VODs because I had a mental breakdown. I will get back to VODs. We'll do VODs. VODs will start going up again soon. I just needed a break. 250 videos went up, and I'm so sick of it. I'm so sick of looking at myself. I don't know how you guys do it. Let's just open recent here. And what I've done is I've taken pictures of the top and the bottom of the board, and then using GIMP, in this case we are flogging the GIMP, using it. I'm not training an AI with my image editing program, and I'm not being moderated by Adobe. What I've done is I've traced top layer and bottom layer traces on this thing, and I've basically just, in their own layer, I've drawn over all of the elements. And so now I have this sort of working design that's laid out for me to go over. We have a couple chips that are unidentified. They've been, the markings have been sanded off, and so it's our best guess what these chips are. And mostly we're identifying them based on their function in the layout. So in order to figure out what this specific one we're looking at, we know that we are in the area of the transistor ladder, because that's what these are. These are, I don't think these are matched pairs, but this is, I mean, very clearly it's a transistor ladder right here. And if we look into the circuit, we can probably get a little bit more information about which specifically they are. The second piece of big information that we have is that this is a 303. The TB303 is a famous acid house synthesizer, and it is from Roland, and Roland has good documentation. Acid Labs does not have good documentation. Roland, however, has amazing documentation. In fact, this is their sort of like fixing schematic, because it's got a whole lot of information about what kinds of signals you should see throughout the synthesizer. We don't have a TB303 though. We have an M303. We have an Acid Labs M303. So there will be differences between this schematic and Acid Labs's device. We were able to find these signals, though, and they deviate just a little bit from specification. The 5.5 to 12 volts and the 5 to 8 volts, they're very, very similar. Our square wave is a lot dirtier for some reason. It's a very dirty square wave we get out of this thing. How it's being generated is beyond my comprehension. I would love to go through and analyze this circuit and figure out how they're getting a triangle and square wave. I mean, obviously, these transistors are doing something. Something's leaking through and it's making that oscillation. I would love to learn more about that. I really need to at some point learn a bit more about these types of circuits. But we know that we have these outputs and we can trace them all the way to right here. This 220 kilo ohm and C17. This actually 1 microfarad is what ours is in this particular circuit. The resistors are different too because they've got slightly different voltage levels on everything. So that leads into the transistor or diode ladder filter. And that I have watched a couple Moritz Klein videos on, and I still don't know what the hell's going on. But we do see the signal go away. It's just gone when it gets into this. So we tried at one point to replace this transistor here where I think the signal's going into, but it is another one of those unmarked chips. And in fact, it is this one right here. It's this one right in the center of view. We don't know what this chip is. Typically, you'd look to see what kind of voltage is going into the chip, and that can give you an idea based on the pins and the voltage, what type of device that is. Like if it's an op amp, they would go into the middle. If it's a microcontroller, it would get 5 volts and it would get it on a particular pin. If it's a 7400 series, it'd get in the corners, that kind of thing. It narrows it down just a little bit so that you can figure out what's going on. This one does not seem to get power. We traced power all around the board, and we found that this one does not seem to get power in the sense that the other chips typically would. You would have a decoupling capacitor and you would have power going directly in. This doesn't have that. So my supposition, my assumption was that this is in fact a bunch of transistors, because we had, in order to repair the oscillator, we had a chip that was a bunch of transistors in a trench coat. So I thought that over here in the filter, since there's about 1 billion transistors in this circuit here, we would have a bunch of transistors in a trench coat. But it didn't appear to work out that way. We need to verify. I need to see what the components of this thing are and where the signals are going. And we need to see whether or not we need to replace individual pieces of this. So that's where we are. And we're going to start with the signal coming into the filter. And I'm going to write this down in my notebook, and we'll have a good time. We'll hang out today. So those of you that are in for a nice boring time, thank you for sticking with me during this. And of course, when the print is done, we'll check in on that. But this is just in service of us poking around on the circuit in order to figure out where things are. Now, I've gone through what it takes to draw a schematic before. I can do it again if people are curious. The chat is like dead. So basically what we're trying to do here is tell a story from the upper left to the lower right and mark things as we go. Now, I will start a new page because this is the stuff in the oscillator area. So let's just flip to a blank page and let's do M303. I don't really like how this thing writes. I don't know if I want to use this. Let's try to find like a bigger marker. Why the rip? What? I'm still going, right? My bit rate's good. I guess I don't have like a big comedy marker that I can use. This is as close as we get, so we'll just use this. Ladder filter. And so in here we have signal coming in, and that would be our square wave / triangle, or sawtooth rather. I'm gonna be saying the wrong thing. Yeah, I don't like how this thing writes. This bleeds in too much. It's too much of a Sharpie. This is a very thin line, so it's not really gonna be that visible, but I'll be much more comfortable using it. So, okay, transistor ladder filter, we have this confusing thing. Let's see if we can get a better... Always wondered how you debug a broken modular device. Yeah, these things are a big puzzle. A lot of the time, if I were to be debugging this thing, I would be like, there would be plenty of information. Like a lot of the time they open source these designs because it's like the electronics expert is going to wheedle their way around and figure out exactly how your thing works, regardless of whether or not you release the information. And then the people who don't know anything about electronics are going to continue to not know anything about electronics and just buy the module, right? You're not going to lose customers by releasing the information on how your module works, because it's a big pain in the ass to build something from scratch, right? So yeah, it's like, it's just one of those things, like, just give us the data we need to repair our devices. It's like, right to repair stuff does not really apply to modular synthesizers, you know? It in a sense, it could, but it's not really that important. For the 303 that we have, the M303, the acidlabs.de modular one, there is almost no information. Boring for folks who do not have interest in this sort of tech. Elsewise, this is engaging for those of us who crave such things, what you're doing, like hardware hacking or reverse engineering. Well, I do appreciate that very much. I'm not as popular as the more exciting streamers. As I grit my teeth and grind them a little bit. Yeah, at least they made it like the OG. Their entire goal was to make the TB303 with modern parts, because the TB303 used some bespoke stuff that was only available in the early 90s, and you know, everything is a production line, and technology moves on, so some things were no longer produced. And so Acid Labs went through this went through this design and updated pieces of it, changed some values to tune things in their particular way. They absolutely deserve all the credit in the world for what they did, but then they sold this thing, made a weird pinout, didn't tell anybody how the circuit worked. So if you looked at the RE303 website where you got these docs from, their RE 909, 808, 303, 101 projects are so cool. I built a 909 over the holidays. What? I'm just gonna build a 909. Just, you know, hey, whatever. Ladder filter. It just takes me so long to do anything. It's really shocking to me that somebody would be able to just build. So I'm looking around for what a transistor filter or ladder filter typically looks like. I'm looking for the most aesthetically pleasing schematic of one. Like, this is not that pleasing. It's almost there, because I have a feeling we're going to be identifying quite a few. I mean, this is the one directly from the okay. The problem with the schematic that I have in the 303, it has all of the controls pulled off to the right side. So there's all these long traces that are these long schematic lines that go over to the right side in order to get to the controls, and that makes you arrange the circuit a little differently, and it doesn't look as much like a flow of left to right that I'm going for. It's fine, you know, this is fine for what it is. It's just, I would rather have something that's more like a pathway of audio that I can understand a little bit better. I guess that's kind of what we're getting at with the ones like this. Kickoff and first filter stage, that's a little different too. They remade and printed the PCBs that you can buy with the bill of materials and fully functional cases. Oh, I see. So you got like a kit and built it. That's cool. I should do something like that again. I should buy another kit that I can build, because it's like brain turn off time, which is part and parcel of what we're doing right now. All right, so generally there's not a great typical form for the transistor ladder filter, but this is a pretty laid out and bare. This one's pretty good. This one generally, yeah, you've got the rules of, you know, you put your power up into the side or wherever you can fit it, and then you go from left to right, generally in a downward fashion, but since this has a big towering centerpiece to the circuit, it moves everything down. So we're generally going from left to right on this, with not as much up and down because of the way that this differential is handled. What up, Matthias Bestie? Matthias Best. I will never pronounce anything correctly in my life, and if I do, it's an accident. All right, so we got our input, we've got our scale and trim, we have a range in there, audio in comes in through there, That would be a trim. And then, yeah, Bob's your uncle. Okay, so this is generally the form that I think it's going to look like. When we start going through the circuit, we start putting it down on the paper, it's going to be a total mess. It can be cleaned up in CAD, or you can write it down again, but the initial form of the circuitry is going to be the schematic representation of the circuitry. It's going to be an absolute mess. And I guess we dabbled with this at the place that I used to work, where you would import the picture with all the circuit traces and stuff. You'd import the picture and overlay the devices on top of the devices in the picture, and then you would connect them all, as they are in the image. It's a pretty mindless way of doing it. And then you would have everything connected in CAD, and you could go through and clean it up and do signal flags and stuff like that. I don't know about that method. I've never had it really work quite properly, because at some point you start to see what circuit elements are in there, what design elements are in there, and you go, oh, I could just rearrange that to this, rearrange this to that, and it's easier if you don't have everything in this big web to start off with. So anyway, let's get down to work here. So we have this, and we know this is the area of the filter, and we know that this right here, this resistor, is our input. So start there, because plus and minuses are a little bit more confusing on this one, although I should leave, well, let's leave some of these elements up. Yeah, these are what we did last time, which was poking around and going, well, it stops here. Why does it stop here? So I need to know a little bit more about the signal that's coming in. It seems like I might have missed something in here, like a trace or something. It's maddening. So yeah, our signal comes in, it hits a resistor. Let's see. Can I get this up on the page at the same time? A used 909 is $6,000. You can build the exact replica for $1,500 with their kits if you know how to solder. Man, we had a 505. We had a 505 back in the day, and I regret that I think it got sold, because the band member who had all the equipment basically died. And yeah, I don't know what happened to the equipment after that, which is unfortunate. He would have wanted me to have it. Let's put the PC up on here. So I got to do a new scene for this. I got to find a new scene. Put this up and do application audio capture. No, we'll do not display. I don't think I want display. Here's window. We'll call this one Glup Shitto. No, I should call it PC. For some reason, Glup Shitto's name has been stuck in my head. This very famous Star Wars character. Okay, on that. Okay, so there's GIMP. That's not going to be very clear what I'm doing. I can also, yeah, I'll get rid of the tool palette for you guys. You guys don't need to see the tool palette. So let's do a little bit of alt action, and we'll bring this one in here. Bring this one in here. And we don't need to see files that are open. You guys maybe don't need that bottom bar. There we go. So that'll be a little bit more clear what's going on. We don't need thermals today. Now, the thermals just give us a little grounding. Okay, there we go. So now I've got my little computer picture here, and I can get rid of this one and this. Well, actually, I want that. I don't want those. At some point, we're going to have to pause for me to go get a glass of water. I had this little 30 carbohydrate calzone for lunch. Nice little 30 carbohydrates. It's great. Really? Did that blank out because it wasn't on screen? Strange. It was awesome, but it was a buffalo chicken calzone, and so it is rendered my guts into pure acid. I've got pure acid in my veins. I'm like an alien. Okay, so we're coming in here, and if all things considered, I'm going to put the schematic up on another page here, and we'll just roll. You guys won't be able to see that, but it's going to be kind of necessary for me to see that. We've got our initial input from, oh my God, wait a minute. I've got too many tabs open, chat. There's too many tabs. Bring this over here. And we'll bring that one over too. And those are all my devices, but let's get the TV303 working document out of the way. Yeah. And then I'm going to put that all the way over in front of a couple chats. Or maybe it should be like straddling these. I don't know. I don't want to miss chats, you know? I don't miss you guys talking. And if I put it in weird spots, I'm going to be looking off in like, like looking in all these weird directions to get the stuff. I guess if I can see it up on screen, then I can put this here. Who the hell is that? Wait, what's going on there? You gotta stop looking at my ass? Jeez. All right, so here we are. So we've got the initial 220K ohm resistor on the input. In this case, we have 1203. And then over here, we've got a 220K. What are you, it's like, is that where the signal's supposed to be going? No, that's coming from over there. So we have what I would assume 1203. So 120K resistor. 120K. Now we don't have any C's and R's on this board. Nothing is labeled like that. I would appreciate not putting values on this and putting like R1, C1, but over here, we don't have that. There's no silk screen on this thing. We're kind of in the, you know, on our own. So the line denotes negative, which feels like this is in backwards, and this might actually be a filter. So I might already need to start redrawing this. That's kind of something that I was playing at the last time we looked at this. This is where we should see it, but we don't. So this comes in, and this goes to a pin of this chip. So we've got a capacitor here in sort of the opposite direction of how I would think it would be connected. And then it's going into an IC, and our belief is that the IC is this thing. A bunch of transistors in a trench coat, which would make sense because this is like this. And we got a bunch of transistors over here. We have an initial 2.2K that goes to this sort of four-way junction where it hits 5 volts and then has a 2.2K coming off in that direction. This is going to get very confusing very fast, but we're going to try to stick around with it. Because see, it comes over here and it goes to our 5.2 volt source. So that junction there, I'm just going to mark that it's going to pin, oh God, pin 2 of our IC. Pin 2, and then over here, we have it also going to 2.2K, 2201, so that's 2200, which is 2.2K, and then over there's the 1K. So that goes to a 2.2K. Now, would it be, well, in this, it's actually specifically looking like that. What does it look like on the good schematic? Where's that? Sort of the way it's laid out here. We don't have a 2.2K. Negative 12 volt there. Audio in to the capacitor. So this would be our 2.2K, our initial input. And then we would have this here. That's actually facing in the direction that we have in the M303, or in the N303. Yeah. It's going to get confusing because everything's called 303. Is this schematic also called 303? No, it's 27543. That's confusing enough as it is. All right, so we come out here and we get a resistor that goes from, okay, resistor junction where it hits a 3904 pair that goes down to another part of the circuit. And so the part that we're getting into in that 5-chip thing looks like kind of like this. So let's see where that's going. I'm trying to explain myself. I usually wouldn't talk this much when doing this stuff, because you'd sit at your desk and sort of go around, like go through all this stuff and write it down and do all that work, right? And so I'm not used to kind of dictating what's going on in my head as I work with this stuff. So it looks like our resistor and capacitor, this would have been the potentiometer that's coming into the other version of the circuit that we have. And then we've got our capacitor in exactly the same orientation. And then we're immediately, without an extra resistor, we're going in here. But there's a bunch of stuff going on over here with resistors. And I have a feeling this stuff is going to resemble more of the circuit. Now, inside of this chip, we have a skeleton. Dun, dun, dun. No, that's inside of you. There's a wet skeleton. Ugh. Let's see. So that's a TL074. I was just trying to pull up a TL074. These are those little square chips. They're actually 2 transistors in a trench coat. And then our transistory doodle is, that's the MC1014. That's Schottky something. That's my 3D printer. What the hell is this? Oh, this is for I still need to do that programming stuff that we were doing. I need to actually implement that. There we go. LM3045. This is what the inside of the LM3045 looks like. So pin 1 is in that lower left-hand corner. Our pin 1, flip this thing 180 degrees. Our pin 1 and our pin 2 is actually going into the transistor in the exact same way. That's why we think that this is a transistor piece. Okay, I'm getting a little bit more confident. I'm starting to build up a little bit of confidence in what we've done. Because, yeah, that goes into the base, and then that goes down into the junction. And so this pin 3, should be going to another transistor that goes to ground. Let's see if that's actually what we have. So pin 3 goes into a resistor and then a transistor, and one of the pins of that transistor might be ground. We don't know. That one's going off in a direction. That one goes to whatever that junction is and back around. So it's a little bit more complicated, but it does appear that pin 3 is going out to a transistor in a sense. So our confidence goes up just a little bit on that. So, all right, so that means that the initial structure is there, and we can jot down a little bit more of this circuit. So at pin 2, we have another junction, and pin 2 is the base of a transistor that has a connection that looks like, okay, I gotta pull up it's just references of references of references around here. Both of those going down to a 2.2 and then into a transistor in a slightly different way than the other one does. This is a little bit different than the other circuit. Yeah, it's a lot of bit different than the other circuit, but it is fundamentally very similar. All right, so I'm just going to write that down then. So like this, and then these are connected just carte blanche. That one comes out there, and this one goes out like that, and I can mark the pins on that, which are pin, oh God, I gotta find that thing. I gotta find the picture of this. So it's pin 2, this is pin 1. That one is pin 5? Pin 5. The base is pin 4. 1, 2, and then this one is pin 3. I'm just going to write them down as P3 just because I need more space. Okay, 1, 2, 3, 4, 5. That's this Q1 and Q2. So that really does appear to match up. Let's get some more of the circuitry in here to see if it agrees with this particular circuit. So we have a 2.2K, and that eventually goes to 5 volts over here. I think there's a little bit of a difference there, but I'm not quite sure yet. Hold on. That goes to positive 12 volt. Where's that 5 volts in here? Positive 12 over here. Yeah, this is just going to be a different implementation of the circuit. It just gives us kind of a basis for which we'd want to like arrange things a little bit. And sort of the commonalities of a transistor ladder filter. Okay, so so first of all, down here, the lower left, we've got a bunch of stuff going on. Over here, pin 2 also goes to 2.2K, and then a bunch of stuff all over the place. This is crazy. So we've got another 2.2K without the transistor ladder. So I guess I'll do that vertically. Right here. Bring you guys in a little closer to this so we can see it in the varying views. All right, this is what I would have been working on apart from stream so that I could show a bunch of progress suddenly, and you guys would then be able to benefit from a little bit more of the advanced stuff. But we're down here in the mines. We gotta figure this one out. So we're doing it this way. So 2.2K right there. And by all means, we should have seen a waveform on these pins. It seems like we definitely should have seen a waveform. I am suspicious of this one microfarad cap, in spite of the fact that we do see a wave at the 1 microfarad cap. And if I test that with the multimeter, I get 1 microfarad. I get an exact reading of what it is. So by all means, everything seems to point towards this thing functioning perfectly fine. But then we go to test it, and it all falls apart. 2.2K goes down to this big, nasty junction. So let's just give ourselves a little bit of room. Let's put a big dot there. And then I've got a 1K that goes to plus 5.2 volts. So here I will actually go, let's see. Yeah, I guess off to the left on this thing. We'll do that just to make it similar to the real thing. So off to the left, I got this junction, and that goes to, and I'll do a right angle and then an arrow, and then label that specifically 5.2 volt. And then this is 1K. There are certain ways that I do things in schematics, and one of them is having all of my positives facing upwards and all my grounds pointing down. So if it's a special ground or a negative voltage, I'll point that downwards. And if it's a specific value, I will label it. Otherwise, it can be labeled V or VCC. If you've got like a 1 voltage system, if you've got like everything's 5 volts, you make VCC 5 volts, and then I won't bother to label them. But if it's like this, and we've got 10 different powers going around, I don't want to leave that to a symbol. I'll just write the voltage right next to the arrow. But then you run into a schematic from Roland, and they've got a circle with a line through it, which we figured out that actually means the 5.2 volt bus. But they don't tell you that. Well, they do actually. Actually, wait, they do tell you that. Wait a minute, it's right here. 5.333. So they do tell you that. I just didn't see that part when we went to research it, and so I scrolled up on the PDF, but it's right there. Okay, so I mean, they do label frequency right here, and that would be a place to pick up. I guess that's frequency control or cutoff. Huh? Okay. All right. Anyway, back to brass tacks. So we've got our 5 point whatever volt coming off of there. This has a capacitor that goes to ground coming right off of the junction. In this case, the other side of the 2.2K. So that makes sense. Now, I only do 3-way junctions. So in this case, I am pulling this down like this. I'll give it a little space, and then our capacitor here, and it's polar, and it goes to ground, and I drew it way too big. And that one is, what value is that? 10 off? Is that what that is? Is it 10 and oh wait, I can just do this. 16 volt 10 off makes sense. So I'll call that 10 off. What is it here? C16, and it says 10 out of 16. 1 out of 50, 10 out of 16. Oh, one off 50 volt, 10 off 16 volt. That is an exact, okay, so 10U. I'm not bothering to put an F on it, and I'm also not bothering to put the voltage on it. I don't really think it needs to be next to it. I mean, maybe I should mark it down just to be thorough. Why not? All right, fine. 50 volt, and then 16 volt. You just get them kind of near, and later on when you revise it, you can come up with a system that you want to use for all of them. This is just a piece of solder that was in the wrong place. Yeah, flannel. I always wear flannel. It's just like my uniform. I don't know. How many non-flannel shirts do I have? Not many. I'm gonna sit here in a t-shirt. I'm not a caveman. What else do we have? So we've got those junctions. So that's our capacitor to ground. That's our 1K to 5.2. We have the 2.2 coming in, and then we have two. Oh no, 2201 and 2001. So I've got a 2.2K and a 2K. That leads to ground? Huh. So there's a 2.2K that loops back to the base of the other whatchamacallit, which will be pin 4. What are you... Wait, you're not... Listen, every time I get an Australian viewer, I think it's my cousin, because he keeps forgetting his screen name or whatever, his password, and then he'll come in at like 4 o'clock in the morning for his time, and I'm sitting here in the middle of the afternoon like, it is you, god damn it. It's the only Australian that watches the show. Has to be a relative. So is that pin 4? Pin 4 over here. 351. That's crazy, man. I used to be up that late a lot. Too much. Pin 4. Yeah, that is correct. Okay, cool. So I think we've pretty much verified that, like, this is the chip that's been sanded off. And the way we've done it is by going around parts of the circuit and figuring out how it relates to the 303 schematic, and then our own, we're using our guide that we created in order to figure it out. Yeah, I don't function that late at night. 4 o'clock is when I accidentally wake up at my desk. Like, ah, shit, I should have gone to bed earlier. I fell asleep. And then I'll have like a kink in my neck the entire day. Pin 4 over here. 2201 over to this whatever's going on over there. So this would be this sort of slung under 2.2K. Yeah, they sanded the label off of the IC. That's part of why we're doing this, is because they sanded the label off the IC. They shouldn't have did that. Oh, I probably should have moved this down significantly lower. I'm gonna have a whole bunch of transistors up here. I don't know how I'm gonna be able to fit. I'm just gonna have to like put an arrow down to something down here. So yeah, this loops around, and instead of doing a 3-way junction, I'm just gonna do an offset like that. Or sorry, I don't do 4 ways. I do only 3-way junctions, because that clears things up when you have the question of, well, is this connected or not? And the reason that it clears it up is that, what was this one again? The reason it clears it up is because when you have a 4-way junction like that, if you forget to put a dot on it and you're not doing that swoopy, loopy, jumpy thing, this thing, where you mark 2 connections as being connected by having it go like swoop, and oh, it's a little tunnel. Like, that's a weird way to draw schematics. I don't like doing that. The difference between this and this is an accidental missing dot. So if you never do 4-way junctions, it's always going to be a non-connected crossover. That just clears it up. So they stole Roland's design and then decided they'd obfuscate it by transistor IC. Yes, they did. Their pièce de résistance, the thing that got them there, is finding these RF chips that have 5 transistors in it. And, you know, that's not that tough to find. And because they're an RF transistor, they have all 5 of the transistors in there are what's called supermatched. So all of the little statistical differences between transistors of the same type, which is like how they get into the switching voltage and stuff like that, those are supermatched, so they're exactly the same. If you were to supermatch something, you can do it without buying a supermatched pair. You need a transistor tester, and I actually have a little circuit board that I want to try out sometime that does that, and it runs it through the voltages, and it gives you like a chart of what that looks like. You can find that data from the data sheet, but statistically, between 2 transistors, between 2 pieces of silicon that have been manufactured God knows how far apart, you can have all kinds of differences between the subtle ways that they get into voltages. And since we're a filter on audio, things are fairly sensitive. You could not, well, traditionally use the supermatched as an oscillator, and that makes you a nice clean sine wave. In this case, we're using it, I guess, as like properties of a filter. But so that chip, while it's not all that unique and rare, it is something that they found, and they decided to put into this application instead of having obsolete parts, because radio has moved on, audio has moved on, but people don't use supermatched transistor pairs all that often anymore. So when you need one, you have to go to some other application. In this case, it's RF, to find something like this that's still being sold. But you can, you don't, if you're building an analog synthesizer, you can supermatch transistors. You can just test a whole bucket of them and figure out which ones have the closest properties. Yeah, transistor matching is a big deal in these and like audio equipment and stuff like that too, yeah. Ran out, I had to buy NOS. The one that I needed for the analog VCOs that I still haven't gotten working. I'm hoping this will help me figure it out a little bit, what those analog VCOs are doing, because I don't know what I'm doing. But in order to run that, I had to go on eBay and buy an old CAN transistor and LM394 or something like that, like a really old chip that was like $14. So it's nice to have more modern and cheap solutions. All right, so far so good. It's looking like this is what the circuit is. Now, what was that transistor? What was that resistor that I just put down? The resistor 2201. Oops, hold on. Wrong windows are up now. 2201. Oops, that's not what we're looking for. Oh, I definitely am closing this one. This is from like last week when I was programming. 2201, which is 2.2K, and that would be, where's my window? I have so many windows open, chat. What's the meme, chat? Is this real? So, 2201, 2.2K. Confirmed. Confirmed for 2.2. And let's see, we're just getting through it. We're just getting through it. We've got all the way up to here. And then our output, we've got like a 10K coming out of this thing. So it's going to go in a couple directions from here, which it does appear to do. We're just kind of like, we're hunkering down and we're getting through the circuit. So pin 4 is going out to a bunch of stuff, 2.2K and otherwise. So there's where it hits the 2.2K below, and then above it goes to a 1502. So that's 2 as in 2 zeros. I don't think it's 2051. We're not counting that precisely, right? So flipping this thing 180, we got 1502, 150 with 2 zeros after it. So 15K. So that's going to be a dot here, a line coming out here, squiggly line, and then 15K. I don't do the euro. When I handwrite, it's easier for me to just wiggle up and down than draw a box. So when I'm doing schematics in CAD, I appreciate the European resistor symbol because it's nice and clean. When I'm doing schematics by hand, I like wiggling my hand around and making these ridiculously squiggly resistors. So It's two ways to get to the same end. It's just the Europeans use a box to symbolize the resistor, and the Americans properly use a squiggly line because we're not pretentious. That capacitor is going way off in a direction. And why do we have two resistors in parallel? Hey, who's that? No Clue 321 with 19 months. No Clue 321, thank you so much for the Prime. By the way, if you guys have Amazon Prime, not only do you get to watch the Fallout show, but you can also sub to this channel. There's a little checkbox when you go to sub, and if your Twitch account is connected to your Amazon account, you can use that Prime on your favorite streamer. Why do we have two devices in parallel with absolutely nothing else going on? And it seems a little weird that they would be like this. I'm a little creeped out by this thing right here. A little creeped out by it. And we can see from what we're doing with the lower part of the board that there's nothing else associated with it either. So I can take a look at underside of the board and where these two resistors are, because we mirrored the underside. It's basically just looking through the board. We can see that there's nothing going on there. So for some reason, they've paralleled two resistors. It's a very strange thing to do. You wouldn't do that in your final design unless you're trying to get a specific value, but because they're in parallel, it's 1 over the sum, or 1 over the sum of 1 over the resistors. So we're doing, where's the square root of 1 over? It's the sum of 1 over the resistors, the square root of. So weird. Okay, so we've got our 15K, and then I'm gonna just do like dot, line below, squiggle, back up with another dot, and that would be 100K. Jeez, 1003, 100K. And then that resistance is, should we just use a calculator? We'll just use a Java calculator. I'm not exactly taking a quiz in school. I don't have to calculate this all on my own. Or I could just use built-in calculator. It's two resistors in parallel, father. Do some real schoolwork. So 1 over 150, 1 over 15. If we'll do all our calculations in kilo ohms. And then 1 over 100. Point 0.07666666. Okay, 0.07. And then we take the square root of that. Where's squirt? Squirt? What have you done with squirt? Oh, I guess I could have used that button. 2 square root of x? Is that's the right button? We don't want log. That doesn't make sense. I'm gonna use a resistor calculator. We have Java applets for this kind of thing. Math and streaming is just not compatible. You can't. Anytime you see a streamer, oh, 1 over x, that's what I needed. So 1 over the sum. Yeah, that's right. Okay. I was on the other side of the number line. I don't know why. Or the other side of the equal sign. Don't you love Java? I love these. I love little applets on websites. It's just, they're the best. You just like, I can't do math. 1 over something. I'm gonna mess something up. You guys saw it. I messed something up. So you go and you search and you find just a stupid little application that'll do that calculation. Some of these get really advanced too. You can do like eigenvalue calculations and stuff. But yeah, it's just, I love my little stupid little apps. So I don't know why they would need 113.043K. And if they're going for 13K, you can get a 13 kilo ohm resistor. Why would they put two resistors in parallel like that? It's strange. It's very strange. But then it goes off to a capacitor. So let's take a look at the big circuit here. There's our capacitor right there. And here they have a 10K. They just have something that's like near the value, not a weird parallel 100. Where did we just go? Weird parallel 130K setup. That's very strange to me. So anyway, we're here now, and that's this capacitor right here. So those go into the opposite direction this time. So this time it's like this. You guys can see what I'm drawing? Yeah, okay. Doot, doot, and then out, and that's plus. I should probably take the doggy for a walk at some point. This is some kind of dead chip. Do we know what this one is? This one is the transconductance amplifier. Code Rushed! Hey, Code Rushed, what's up? So, here we are, doing our thing. Hovercrafts are outside behind me, so it might get a little loud in a minute here. And maybe the dog will start barking, but she's in summer mode. She's sleeping right now. We have a M303, and the M303 comes from acidlabs.de. Acidlabs.de makes this modular synthesizer module that has absolutely no shroud over the power input thing. And so they give you this weird plug that can be plugged in on any of these, and it turns out audio guys are not good at plugging things in properly. And so very often they will blow up their M303. Enter Dave. Dave one day was sitting down to reconfigure his modular synthesizer setup, and he plugged in his M303, and he plugged it in wrong. And so he ended up blowing up the circuit. So he comes to me, professional electronics fuck up, and he goes, hey, can you fix this? And I go, sure, of course I can fix this. Look at all this shop that I've got. Well, turns out, in our attempts to get this thing testable, I blew it up. Plugged it in backwards, as in this header was plugged into this header and vice versa. And so something happened to the circuit, and I think I broke a little bit more than typically breaks. So we've been trying to repair this for a while, and then Dave died. No, if Dave died, then it would be on me to repair this. Nothing really explodes too bad when you plug this thing in wrong. Things just kind of heat up. But we've been trying to figure out what this thing does. And the M303, wow, I just heard a big pop out there. It sounded like the lawnmower might have run over a stick or something. There's a big psh, like a stick slamming into sheet metal at 1,000 miles an hour. Oof, hope their equipment's okay. So yeah, we don't know what's going on this thing, but we do know that it's an M303. The TB303, the beloved synthesizer for most of your acid house needs, the TB303 has a very similar schematic, because that's essentially what they went to reproduce with this module, right? They said, hey, we love that 303, we want to put it into a modular synthesizer. And so they created almost to the T the schematic for the TB303. So we have, from Roland, we have a schematic of a TB303. We have chips on this board that have been sanded off that we don't know the identity of. And we have pictures of the top and the bottom of the board, as well as Spider-Man. We've got pictures of the top and the bottom of the board. So using all of these things, we are amalgamating all of our knowledge and trying to produce a working document that'll give us an idea of what the structures are on this synthesizer so that I can fix it. Because we've traced the signal, the VCO, the voltage controlled oscillation portion of this synthesizer works. We have a signal. We can trace it throughout the board. We can trace it to the filter where it dies. And so we're looking through the filter right now, and we're trying to mark down on paper what is here, what is where, and then I'll know where I can poke my probe and figure out what's broken. Now, we've already replaced that chip, and we replaced it with one of these 5 transistors in one package things, and it didn't work. Although, you know, we kind of made the assumption that that's what the chip was, and it looks like we're right as far as the connections go. So far, what we've run into is, if this were that device that's 5 transistors in one chip, then we are correct, or whatever. All the connections are correct. This is what's inside of that chip, and it would be flipped 180 degrees. So far so good. We've identified that pair that's connected together, and the circuitry around it looks a whole lot like what's in the schematic that we have for the 303. And that's what we're figuring out. So welcome to boredom, Code Rush. Thank you for rating. I really appreciate you guys. It's a lot of me explaining, you know, what I'm thinking and what I'm going through, and sort of what my mindset is. You know, why am I doing this? Why am I clicking on this? Why am I doing that? Good times. It's very complicated. All right, so we've gotten to the other side of this capacitor here, and then this goes and it travels all the way to what we're assuming is a TLS72, a dual op amp. So this goes over to a unity gain op amp at that point, which is all the way over on the other side of the board. And then this is a transconductance amplifier. We got this one because I believe Ben Gizmo told us what it was, or one of the viewers deals with circuits that have these a lot. When you're dealing with an IC that you don't know what it is, a lot of the stuff that makes an IC unique, you know, it could be any ASIC in the world. They could have put whatever in there. You never know. But you can get close if you look at the surrounding circuitry. Where does power come in? Where does our signal come in? Where does our signal come out? And so we looked at this, and somebody in chat was like, hey, I know that. That's a transconductance amplifier. This would be the voltage-controlled amplifier portion of the circuit. So this is where it exits the filter. And we now know that these 2 resistors and this filter are a place where we can actually probe in order to figure out what's going on. You know, what's broken. It's not getting out the other end of this thing. Let me just make sure. So that's a 50 microfarad. No, it's not 600 volts. That's a 1UF. Okay, so it's exiting 1 microfarad. That's, for some reason, it's in the other direction. Let's see what we've got on the main schematic. So that'd be C23, and it is in that direction. Okay. So we enter through plus, and then we exit through plus. Wait, no, but this one's opposite then. No, it's not. That's in the right direction. Okay, so no, that's weird. That is backwards. Why is that back? Well, not back. I mean, you know, it's probably installed correctly because this module worked. I just don't know why it's in that direction here. It's in the opposite direction in the other schematic. Going into the plus, going into the plus. No, wait, no, I'm wrong. This goes into plus. This one, it's this one over here that's weirdly in the wrong direction. This one goes into the minus instead of going into the plus first. I see. And then pin 1 goes to, yeah. Pin 1 goes to the transistor ladder. Pin 3 goes down here to a couple more things. So we'll have to look into this in just a minute. But we've got the exit, and that's 1UF 50 volt. So 1 UF above. Oh yeah, these are up there. 1 UF there, and then 50 volt down here. And that's our capacitor. Okay, so now we can look back at the rest of the circuit, because anything between those capacitors is sort of what we're trying to figure out here. But now we know where to probe for input and output voltages. So what have I not done yet? There's quite a few places that I haven't marked down. The ladder portion of it, I mean, we know that's this, just because this is like very clearly with the transistor ladder, you're using transistors kind of as diodes, and they go up to positive, and I don't know exactly how they're treated. I don't know exactly what's going on the inside of this thing. I watched a Moritz Klein video, and he explained it in length and in detail. I just don't know. I just don't know. So this thing goes eventually, okay, sorry, where are we? Right here. This goes all the way to a TLS72. So let's just double back on this. That going out here. Oh, shit. Wrong way. I'm looking at C23. And it goes to a transistor. Is that amplifying? 10K to ground. Huh. Yeah, so that's different. This is different. It's actually going to an op amp in ours, and there's no op amps around. This would be the output over here. No, it's not. 15 millisecond key. C adjustable VCF. That would be one of the adjustments, I guess, for resonance? Huh. Also goes down there, up and over to here, where it goes into an op amp. Where are we with this op amp? This is the voltage controlled amplifier portion. So I guess, yeah, all of that stuff over there is the VCA. And is that the transconductor? What is that thing? Oh, I see. It's another amplifier just in unity. Ooh, envelope is kind of a scary place. Let's get away from envelope. let's kind of veer away from envelope there. So we know the transistor ladder. We know that section. Then there's another matched pair over there, and I have a feeling that's going to be part of the IC. We're still looking at our signal path, and we know that it's coming out of C whatever the hell. C23 appears to be, well, that's not really our signal path, is it? Where does our signal come out from? That's the wrong view. That's the microscope. I was on the right view before. Okay, so signal output where? So it looks like it veers off and gets a trim, at least in this circuit. It veers off and gets a trim, but it does come out of that side and then mix back in with whatever we're taking through an op amp at the two locations of the transistor ladder. And it appears as though we've got our supermatched pair at the bottom, but then we got 1, 2, 3, and then we've got 1 all the way at the top of that. The 1, 2, 3 is probably there just because of the voltage levels, but 1, 2, 3, and then our output over here goes into another supermatched transistor pair. I don't know what configuration that's supposed to be though. 100K, 10K, and that going down like that. I don't know. Some kind of a thing. So I guess but then it would mix back in with the stuff from down here. This comes up and it goes over to resonance, and then it comes back over and goes, right there, okay. So this is where it mixes back in. I don't know, did they just like make an op amp but more complicated? This is very strange. Well, let's see how close the it seems there's a little variation in this portion of the circuit. So let's see how Acid Labs figured this one out. So at the after 3 of the stages, I guess, of the transistor ladder, we're getting a differential out across a capacitor. And then we've got a matched pair sitting above that. So that is then over here, we have our pin 4. 1, 2, 3, 4. Pin 5 goes to the transistor ladder. And then these look like this. One of these will have it. They look like, we don't need this. We don't need that. Okay, look like this. So CB, EBC, CBBC. And do we see the line on it? We don't. Luckily, we still have the circuit here. I was afraid we'd actually fix it, and then it would go to Dave, and then I'd never see it again. I'm reflecting light off of the circuit board to try to see what direction these little transistors are. I don't see that extra line on it though. There's supposed to be like a little line on it marking our pin orientation. Oh, there's also a dot. Is there a dot on this? I ain't see no dot either. Jeez. These are... All right, let's see if we can get on the microscope then. This is an unfortunately slow process we're going through here. There's the dot. It's in the upper left. So it is indeed the configuration that is in the data sheet. So it's where's my pen? So we've got collector, emitter, base. And then it's collector, emitter, base. The two bases are in the middle. So I'm going to go to that layer where I have the this drawn out, and I'll draw out the transistors on that one. Go to white. Make sure I'm actually selected on the layer, and use the pencil. Yeah. What's up, esports? Nope, 3 is too big. 1 pixel's too small, but I guess we could just use it that way. And then what does this thing look like? I'm doing this so that I don't have to keep looking it up like I am. Move this to the other screen. So it's like, dude, what? Why did nothing happen? Pencil, white, this layer. Oh, you know what? I transformed, yeah, layer to image size. There we go. Now I can draw on it. It didn't have all that canvas there. It was only that little thing, and it doesn't let you go outside the dotted line. So yeah, we have a little blocky thing there, and we got a little pointy thing, a little arrow coming out. That's not an arrow. Yes, it is. You can totally see it. Like that, and like this. And then we got another one. This one instead goes here. That. And then the arrow goes upwards. Yeah, it's like this. Like so. That's hard to see, but it's sort of like crib notes. It's just like crib notes. It's just my own notes for the for when I'm drawing it. And then another one here, where it goes like this, and then this, and this. Oh, that's a terrible one. Then do another one. I could probably cut and paste, but I'm drawing that, and then this one like that. So we've already, I mean, just at the outset of this, we've already got a bunch of stuff that we can now test in order to figure out what's going on. There's some more areas that we can poke where we will want to see stuff happening and be able to actually figure out what's broken, what's dead. So the base of that little weird junction going into the transistor ladder and looking at the Roland schematic, base of that, that goes into these, but then, yeah, the base of, okay, so they should go to either side of the capacitor here. So one side of this cap goes here, and then this one goes to the other side of the cap. All right, just as we predicted. Okay, so 1, 2, 3, and then we're at the outset of the transistor ladder. There should still be a matched pair at the top of this thing, which I'm guessing is what they're doing with some of these other ones. So 1, 2, 3, we're at the top. We're at the very top capacitor, and then we come over here, and it looks like these two are going to be the the transistors at the top of the ladder filter. So that means that our output from the ladder filter is here and here across this capacitor. So yeah, so far so good. Everything is as predicted. Oops. And at this point, I'm willing to have full confidence that the chip here is the same chip as right here, where we're creating the oscillations. We have another, or no, where is it? This one, or whatever. Two of these are the same thing because they're creating oscillations with transistors, and then they're doing a ladder filter with more transistors. So cool, cool, cool. So now we know that all stuff goes to there. I don't have room for the remainder of the transistor ladder filter, so I'm just going to do a box and just say ladder filter. Ladder. And there's a capacitor. And then at the top, according to the M303 and not Acid Labs, we would have a matched pair going to a couple things, including a 100 ohm resistor that goes to power. So 100 to power. Oh, but that's this whole power section is behind like a 100 ohm thingy wingy. And we should have a capacitor to ground and a 10 kilo ohm. So on the pins of those, and the pins are going to get kind of weird here. Oops. Pins are going to get a little weird. We're going back into our transistor over here where we go to pin, well, why is that one going to pin 5? Oh no, it goes under the board, I see. It goes under the board where it then goes to pin 6, 7, 8 or whatever. What's this transistor doing? We got a couple of these right over here. Huh, some switching stuff. Okay, so back to concentrating on what I'm talking about. We've got this capacitor right here, which is the one that I just drew, and then those go to this section of transistors, and it looks like it is in that configuration. What's unique about the Roland configuration? What is it going to look like? It's going to look like both of the bases are going to be connected to one another. Does that stand to reason? That would be this pin going under the board and going to the base of the next one. Yeah, so that's pin 1, 2, 3, 4, 5, pin 6, and pin 9. So let's do it like that. Okay, I think I see what I'm doing. Down like that. And those go to the two sides. My drawing is going to be like wild. It's going to be all over the place at this point. This is one of those drawings where you'd have to do it many different times in order to get it just right. So those are connected to one another. And then those pins, I'm going to mark those down. So that would be pin... which one is which? It's symmetrical, but the ones on the other side go to pin 1. So pin 1 is there. And so that would be this one. So pin 1 is the one that goes to pin 1, 2, 3, 4, 5, 6, 7, pin 7. So that would be, wait, which pin 7 is the, yeah, P7 there. P7, which means the other one is 5, 6. P6, and then P8. P8, and then the other one is on pins 9, Emitter is on pin 11. Pin 9, pin 11, pin 10. There we go. So that's every pin of the IC, well, except for the last three. That last transistor we haven't accounted for yet, but every pin of the IC appears to be doing exactly what we thought it was. So I'm confident now in saying that that is definitely a one of those 5 transistor chips. So no, we didn't blow it up by putting that in there. we might have put the specs off by a little bit because it might be a slightly different transistor. But I think it is compatible and it should probably have worked just fine. Oh boy. Yeah, so decoding the rest of this thing would be more of what we're doing. Hold on a second, is this still going? I mean, Benchy's gonna take 3 hours to create, right? I'm gonna check in on this printer. So it looks like it's running, and I can see in the plate a little bit. The question is it empty? I'll wait for it to lift. I don't think I see anything on the plate. Do I see anything in the vat? I don't see anything in the plate or the vat. I just got to keep letting it do its thing. I've been having trouble with Benchy not sticking, and I guess the way to get around it is to put some supports on it or something. That'll give it a little bit more surface area on the plate where it won't get lifted off. All right, back over to here. Chat is dead today. It's a Thursday. Code Rush raid is the only thing keeping me alive at this point. If this print fails, I don't know what I'm going to do. Maybe have a little cry. But yeah, it's definitely something wrong with the FEP and sticking a little too hard. It's not anything wrong with the FEP. It's probably just the surface area exposure, that the amount of surface area on the of the print sticking to the bed. Basically, it's outdone by the FEPs being a little sticky, which I guess is just how things go with this type of 3D printing. But it means I'll have another Benchy slug sitting on the bottom of the thing, and I'll have to add a bunch of supports in order to keep it supported. I didn't think, you know, when I did the supported Benchy, this one, the one that turned out like perfect, except for that bottom layer, I had it at an angle to the bed, kind of like this, and all the supports came up and met it. And I didn't think that surface area would be more, but I guess, I don't know, printing those supports is like easy for it to do. I don't know, man. All right, anyway. So looking at the areas of the circuit, I mean, there's still a lot left for us to do. We've identified most of the path of audio, but there's a couple other sections in here, and these other transistors, we could probably figure out what they do. If these are 3904s, I can hit those with hot air and replace them in a minute. And that appears to be what we have in this other, one. They labeled them all as 3904s. Which means that they're just your generic, normal old transistors. Sorry, I'm looking for that particular... Where'd my stuff go? There it is. Like, this one has 3904s in the entire ladder. So I have 3904s in stock. Like, I stock those. I buy them by the bushel. My cousin fell asleep. It was like 3:30 in the morning for him. I hope he's asleep. I didn't know that was another one of his screen names, too. It's whenever I have an Australian viewer. If you're Australian, identify yourself in my chat, so I can yell at you for being awake at 3:30 in the morning. It's always on a Friday, too. He goes out and he's parties, and then he comes home and opens up my stream, and I'm sitting here going, well, today we're doing something really boring, putting together a schematic, and he's probably just like dies of cringe right there. He just falls asleep. Why would you click onto my channel? It is so boring. Okay, so we know most of our transistor ladder is there. Whoever designed this circuit puts it into an op amp. Where's ours going? Well, we know that it's coming out over here on This tab, you can see it. I mean, you can see it. This tab and this tab are the differential outputs of the ladder filter. And then over here, we have the two transistors that are above, essentially, the thing. And pin 11 and pin 8 should be connected to one another. And out from that, we should have a resistor capacitor. So pin 11 and pin 8, that's 8, 9, 10, 11. Well, look at that. We've got a nice little fork right here, and they come down here. Have you tried hitting it with a hammer? That's practically where I'm at. That's where I'm at. That's why Desperate is in the title today. I'm beside myself with this frickin' circuit. That is a 4701. Is that what that is? What's up, Jalopy Jones? How you doing today? 4701, so 4700, which is a 4.7K, which is fairly common in audio stuff, I find. So 4.7K goes between the 1s and 8s. So the outputs, and then it also goes to those two. So it's between here and, how am I going to draw that? How's it drawn in some of the other circuits? This is why we have other circuits as inspiration. When you find out the forms of stuff, you find sort of the commonalities and you try to replicate it. So in this case, it's like that. And then the positive 12 volts is on the other side. So this is the 4.7 that we're looking at right here. You're very talented and I know you know your shit. The aggravation is real. Yeah. It's just one of those things. You struggle. Yeah, those are all connected like that, huh? I guess that's how they're displaying their ladder. So I guess then over here we would have these two would go. We just do that out here. So I'll go to the left with this. Oh, there it is. Okay, I was like, can I do this on the Stream Deck? I really need to get that Excel working. It's really obnoxious that I haven't gotten it working yet because it creates all these problems with me being able to control my show. Okay, here's our 4.7K. This sucks, and I did this to myself by starting the circuit right here. I should have gone way further down, and then I wouldn't have had to use a yada, yada, yada right here. I did a ladder to basically yada, yada, yada part of the circuit. What are our resistors in here, or do we have them? At the stage of this ladder, do not look like they have resistors on them, and maybe that is true to the schematic. The one that we're looking at, some other person's schematic does have resistors, but in the TB303, there are none. Okay, so there aren't ladder resistors, although we do have a ladder of types going down to Q20. So we're looking for, I guess, these two now for Q21, because we've got our two signals that come out of this thing, but our part of where our two signals goes into Q22. Now we have identified, okay, so the 10K becomes a 4.7K, and then this technically should be power, but it may go through some stuff in order to get to positive voltage. Let's just see what it does, see if we got a C30, which would be a 10 microfarad 16 volt, according to their notation, their shorthand right here. So if we go over to our 10 microfarad 16 volt, tucked away, geez, okay. 10 microfarad 16 volt, but that should be on this junction here, 4.7K, 1016, but that's on the wrong side. Where's that coming off of? That comes off of the tracks, the bass. Who's in your face? Comes off of there. So that would be like here, having this, and it goes to ground? Yes. Oh, I see. That one goes to ground too. 1.2. Where's that coming from? That's coming from another capacitor. Oh, we haven't gotten to that part of the circuit yet. Oh, I see. Okay, so then that goes to ground there, and for me, ground is a hollow arrow. Is a hollow arrow. 10, 16, so 10U. I'm gonna run out of room around this drawing right now because there's a lot more stuff that needs to be noted down, and yeah, well, right now we're sort of in this branching area right here. So we're over there, and this is the part of the emitters. So this would be that big shared junction that could go to positive power. And it looks like we've got another 10, 16 on this one. So that's over here. I can just put a dot, nice and easy, and go boop, 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 boop. 10U, 16V. 10U, 16V, coming out of there. That junction... What? It just stops over there. That doesn't make any sense. Hold on a second. That junction goes to the capacitor, and then it's got a resistor. It's got a 100, so it's an easy 1K resistor right there. So, okay, so that goes to a 1K. I don't remember, so I got to mark it below. Goes to a 1K, and then it comes out here. And it goes down to a mystery wrapped in an enigma. Goes to that transistor right there, which appears like it's facing another one. So okay, we know where we are. So this little cozy thing right here, where are we? Right here. These two transistors that are facing each other, these are part of the things that get replaced when the thing blows up, I think. No, maybe one of them. Well, no, we're not doing beep boop yet. We're not doing beep boop. We got to fix this thing, and then it'll beep boop. That's what the whole thing is. You know, nobody's making acid house with a broken synthesizer. We got to make that noise. We can't right now. Okay, jeez, you guys just get it wrong. You just get it wrong. So why would you do this? Oops, sorry. I need to open up the other schematic and take a look what REing did. So here's Rolando, and they are putting it into 2 transistors. So each side of this goes through a capacitor, a 0.1, and then goes to either side of a transistor. That doesn't really seem like that's where we are. This is showing a supermatched pair. These are certainly not supermatched, but they're coming off of the top section. So there's some kind of a power thing going on here, some kind of a power struggle, because we're at the power line. That's what this is supposed to be. On a typical one of these, you would just have like 12 volts at the top. Now, I'm also building a diode ladder circuit from Hajiwo's designs. Oh, and that reminds me, I need to order resistors. We need to do that right now before I forget. Pants and resistors. The staple of any economy. I need to order pants just because my khakis ripped. I was putting them on, and my foot hit the knee section of the khakis, and it just split the front open. It's like, why? I've been wearing them too much, so I need to get like 4 pair of khakis. I gotta remember to do that after stream, after walking the puppy, of course. I wish she would hang out down here. It's nice and cool down here. I don't know why she hates hanging out where I'm like yelling. Anyway, oh, that's the wrong PC. I need to get resistors, and I need to make sure that they're thick enough that they're going to work with my breadboard, because we went through that. It's so frustrating, these 1% tolerance resistors that are thin. They're like 1/8 of a watt or something like that. The wire's too thin. They're not compatible with the solderless breadboard. Let's see if, I mean, Amazon is just going to be an absolute shit show, but maybe I can find what I'm looking for. I need the 1/4 watt, and in spite of what they show, I like how this is the overall pick. Sometimes they are not the right thing. Oh, God. This is going to be a shit kit, isn't it? It's going to be very annoying to work with. The ones I have, there's like 10,000 values in them. And I'm willing to spend some money to actually get the right thing in this case. I think I bought something like this, and it ended up being a bunch of the thin, like these have got to be just like a little bit cheaper. You got to watch out for them though. They don't work with solderless breadboard well. They do work, but with solderless breadboard, you don't get a clamp on the leads. Yeah, these are wrong. What is the wattage of those? A quarter watt. I'm looking for... See, this says quarter watt too, but this one appears to have the appropriate size leads on everything, unless those are thin. Yeah, a quarter watt and a half watt. Half watts are huge. But the regular, like, normal quarter watts should have thick leads on them. It's those precision ones that for some reason don't have the right lead. I'm going to open up a new window for this, and we'll look elsewhere. It's Bojack. This is, I think, the one that I bought, 2600 piece. This one is far fewer, but with fewer resistors, if they're actually working, that'll be fine. 50 values, 10M. What's this one again? It's 130 values. Mixing resistors is fine. I want to find like a giant kit of the right ones. But I don't think anybody's selling a giant pass lock bypass resistor kit. For Chevy vehicles? What is this? What is this? What are we doing with this? Spring lock connector for us as pass lock bypass kit for most GM vehicles with pass lock 2. Simple permanent connection, no soldering screw, blah 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 blah. Compatible models. It's some hack that they've made into a regular thing. After 5 ignition switches from Chevy dealer, a well-known auto shop to temporarily mask the problem, which they knew all about. Jeez, okay. I love things like this. That's so specialized. Cement resistor? That's kind of weird and neat. Make a whole circuit with those. So it's like shocking what you're looking at. This one is probably the same thing. 850 versus 1000. I think the Amazon pick wins the day. And I'll just have to 100 values. This one's 100 values. This one's 25 values, so I'd rather get the loose kit. I can throw them into something, yeah. 1 to 10M. These are the big boys. These are half watts. Like $9, $13, like let me spend $30 and give me a giant kit with everything I need in it. But no, I can't. Apparently I won't be able to find that. Quarter watt 1K. That's something to order separately too. 100 values. So these are both, that one's 25 values. This one's 100, but they're big beefy chonkers that I don't need the big beefy chonkers. It bypasses the key code requirement for the anti-theft system. It's 1 resistor. That's kind of crazy. What's this one? This one is a variety of boys. I just need quarter watt. You know, you get to a certain age, you know what you can handle. All right, these aren't bad. How many different values do we have? 10 of just about everything under the sun. This one's only 400 pieces though, and they're 1/8 watt. So these are tiny little ones, but they do have big wires on them. Need a kit that is 99 of the wrong value, but maybe 1 of what you're looking for. You reorder parts on a basis of like what you use up. So you'll actually find that, here's what I was looking for. This is exactly it. Oh no, this is a half watt, never mind. You know, I'll get this kit and it'll be missing resistors in a few places. If I get enough of the values, I'll end up burning through some of them and then getting others, like, you know, getting replacements for them by the bushel. It's just that these freaking things are everywhere. Everywhere. Even these look like they have, I need the thick lead ones. I guess the higher wattages will have the thicker leads, but these would be the ones that would work with the breadboard. They only come in like tiny assortments. I need the big boy assortment. Because whenever we're breadboarding, I mean, it's always, you know, when you're doing experimentation, you get all the weird value stuff, and you don't. I have tons of surface mount. $1K. What am I looking for? So the resistors that I have in my through-hole stuff that I use with the solderless breadboard, right? The solderless breadboard was really, really frustrating to prototype circuits on because my resistors are so, the leads on them are so thin that they're barely even held in. So I need resistors that have normal sized leads over everything else. 1% doesn't matter to me. I need thick leads is what I need. Now these, 1 watt, half watts, those will have big leads on them. So those will definitely fit just fine. But the resistor is this giant chunky thing. I need a resistor that's a normal sized through-hole resistor. I hate this stuff. I hate through-hole. I don't like it. Everything is bulky and weird. Surface mount is so much cooler and makes so much more sense, but you can't solderlessly prototype with that. I can't sit down at my desk and build a circuit in 10 minutes. There are some ways that you can prototype surface mount, and I use them, but I don't want to solder a circuit the first time I'm testing it. I want to be able to just throw it up into something like this. And that's been part of what the big book of circuits, has sort of burnt me on in the past couple times we've tried it. So I'm going to get big boy resistor kit, and then we'll proceed from there and try to build another 1974 circuit. But right now, I just have to find the right one of these things. So these are, I think this is actually what I'm looking for. 1,200 pieces, 40 values. That's a lot of variety. I don't need 30 of each though. That seems a little bit much. I'd rather have more values than repeat resistors. $7.99. The price. It doesn't need to be this frickin' 1/4 way is normal size. Go blue 1%. I use 1 watt carbon film. No. I already have. That's what I'm literally showing right now is the type of resistor that I can't use, because all of the Amazon ones come as 1%, which is great if you're prototyping. That's great. The only reason you don't use 1% is because of cost. But like, and especially if I'm doing like precision circuits, having just the stock of 1% is fine. The problem is they're all 1/8 of a watt or whatever, and so the leads are all super thin on all of them. And so the super thin leads they're not compatible with the size of the pinchers inside of my solderless breadboard. Right, never fails. Why don't you do a thing that is exactly the reason that you're doing this? I know not everybody is read up on exactly what I'm working on at any given moment in time, so. Resistor kit assortment, pack of 680, 34, not as many values, 1/4 watt, and then we don't even know what they are. They're probably the 1%ers. Yeah, they are. It bugs me, like they're all so cheap and they're all so limited. 55 value, carbon film, 1%. Oh, those are huge. I don't need 1 watt. Oh God, no. 1/6 is the small. Yeah, my problem is the tiny leads, but they're not, look, half of the kit's on here, right? And the reason I'm using Amazon is because I'm able to actually kick off a literal Rube Goldberg machine of human exploitation every time I order something. No, the point is that I don't pay shipping on this, so. Yeah, DigiKey would probably have exactly the assortment that I'm looking for, huh? Extensive documentation in a lead diameter. Yeah, that's the thing. It's just, yeah. So work for a place where you got free samples. Must be nice. This is the closest thing that I can find to what I was looking for. It's only 25 values, but I mean, we can deal with the fact that it doesn't have some stuff. There is this one, but this one's 1/2 watt. Does this seller have... Oh, the veritable Arc-Selly brand that everybody knows about. Look at this. Bugs me. It's like, well, these are the bigger ones. Oh, okay. I guess I can get merch. No. So resistor kit, quarter watt, 1%. Quarter watt, 1%. Most of what we're going to get now is the blue ones, because those are 1%. But I need the wire size to not, sorry, the lawnmowers are going by right now. 50 values, 1350 pieces. The risk that I take is with the lead diameter. It's hard to read the code on the blue resistors. And this is another reason why I love surface mount. Because the literal value is written on the surface mount device. There's no guessing. There's no, is that indigo or is, and blue is a very difficult backdrop. They should have used white. But I guess they were probably like, well, this glue is more expensive and this glue is, this is cheaper, this is, I have a feeling dollar signs are what dictated most of the design. These resistors here. And get my calipers. I want to solve this issue because this is a really annoying one. Yeah, I can't just like walk into Radio Shack and get a big kit like these things have. This is all a numbers game. So these are unacceptable. .0135. Yeah, Radio Shack, it was like a couple dollars for like 5 resistors. I'm not going to get specs on the lead size, am I? Only like DigiKey would I get that. But it's 0.35 millimeter. I have to use the bathroom soon. I want to wait until the lawnmower guys are a little further on because I probably need to walk the doggy. We need Oh Bother merch. You know, I'm thinking about that pretty hard actually. I haven't done anything. I haven't done any work in that direction. But the chip on a sticker is something that I have because Twisted Sister made a bunch of them and sent me them. I have a bunch of them sitting in here. If I can get a place that'll print stickers to my liking, the chip sticker is a great thing to just paste, anywhere. A lot of people have rose tinted glasses for Radio Shack. Yeah, after like 6 months, the entire Radio Shack electronics cabinet was completely disorganized, and stuff was popped out. Little shits like me would go in there and steal components. Like it just was not. It wasn't a good thing. Fry's had a pretty good one. We never had a Fry's around here. Micro Center now has a really good hobby electronics section. Every time I go to Micro Center now, I make sure that I buy something from that because I'm petrified that they will go out of business. But yeah, a lot of places are much better than Radio Shack was. I have to poop soon. Do we get a lead diameter? Upgraded version, resistors with +1, minus, quarter watt metal film and thicker metal plates. Better connections, stable performance. I don't care about the internal. More humanized design. The design is very human. Oh, did you get one relatively nearby? It's worth like a half-hour drive because you'll spend a whole day there. Death of Fries. Listen. Fry's mascot looks a little bit too close to my. Let me tell you, my emote, where I came up with it, I sat down and I said, okay, a lot of these little channels, people who aren't artists like me, who don't want to pay for emotes, will jump into MS Paint and they'll make something terrible. They'll make something terrible. And it'll be a resistor, or it'll be an oscilloscope or a wave, and it'll be in MS Paint, and the color contrast will be too sharp, and there will be pixels everywhere, and it'll look terrible. You get 3x3 pixels to create an emote with. And so I needed something that was bold and it would scale up. And I said, Google's got some cool emotes. Why don't I just steal those? The Google Blob emotes were the
kicking off point for my emotes. And so I looked at the Google Blobs. I said, well, I could just transfer like the arms and the face, you know, from one thing to the other. I can basically take their concepts, steal the work of their entire design team, and make my own emote with it. And unlike a lot of electronics channels, like their logo is going to be a chip. I don't want to have a chip. And then I thought about it for a while, and I went through a couple options, and I said, I guess I have to make a chip. Unifying the design of all of the stuff in the channel. I don't want to have a bunch of discombobulated emotes. I want it to be immediately identifiable as an oh bother emote. This is an oh bother emote. This is not. The Willow emote, of course, is just Willow. Can't do anything about that. Okay, a soft schematic symbol for a chip. Cool, let's try that. So I tried it. I said, all right, if it's a Google Blob emote, then the background is going to be yellow. So it'll be a yellow chip. Not a lot of people have yellow emotes. Yellow is very easy to see in bright and dark mode, as long as it's framed properly. If it's framed in black, it's almost impossible to see in dark mode. If it is framed in a sort of light, weird gray, now it works and you can see it in dark mode, and it's not jarring in light mode. So that's the process that I went through in order to create all of my emotes. And then I found emotes that I liked, you know, from other channels and things like that, and I just basically stole the core and brought it over into the chip frame. I've got all the GIMP files, you know, the layered GIMP documents. Message redacted. Uh-oh, I missed that one. Oh, it's still there. On eBay, it's there, and then it's redacted on the other window. Huh. Yeah, eBay might be the best way for me to find those resistors. But so yeah, all that stuff led me to my emotes, right? So we've got yellow chip, we've got the frame outline, the interior, you know, would be a face of like a blob emote, and then arms are discombobulated, they're just detached things, right? And then for the most part, it's framing another emote and like sort of getting the design elements from it into that chip. Fry's Electronics mascot. It's like exactly the same fucking thing. It's the same thing. It's the same thing. It's just really badly drawn. I didn't intentionally make it exactly the same thing. So Fry's having died a pandemic death is not that big of a deal to me. Good riddance. You badly drawn, pamphlet photocopied piece of shit emote that looks exactly like the thing I came up independently with. All right, so the human design, these very human designs. They don't tell me what the width is, so I can't trust this. I can't really, I mean, these, knowing the commonalities between all these things, it does look like they have very small leads. These are very tiny little leads on these things. I need those larger leads. Send me an email. I'm not going to get it for a little while. I'm just going to order the bad one, and we'll see what comes in the mail. Those leads do not look very big to me. And it won't be 1%. I'll do the 40 value. It'll be an $8 mistake. And then from there, I guess I can go to eBay or something and look for a big kit. If they're not 1% tolerance, it's not the end of the world. It would be nice to get 1%s that are thick-leaded, but... Yesterday, I built the frame of the Prusa Mark IV. Today, I put together the Core XY. Well, that sounds fun, actually. That's a lot of fun. That does sound like a lot of fun. All right, so I need your... Just ordered something. Hopefully it'll be good. So we may see an oh bother store in a major city. Not after Fry's sues the shit out of me. They're going to sue me down to my shit. Okay, we've got most of this stuff identified. The circuits, of course, are very, very similar, but do you manufacture your own PCBs or do you order them? There is no no force in this world that will make me go through the trouble of manufacturing my own PCBs. PCBs are complicated, difficult. They're made to a precision that I can't even fathom. While photocopying and acid bathing and heating acid up sounds real great and fun, or routing it on like a router, CNC router might be great. I'm not going to do it. The CNC routed boards work if you like really want to make a prototype today and you happen to be able to design stuff really quickly. You put it all together, you put it on the CNC, goes, man, makes all this noise, and then it creates this really bumpy, jagged board you can then solder stuff to. Cool, like that's great. Everything is in-house and wonderful, but I got a $5 bill and no room for chemicals or dust. So I send out to, I use Seed Studio, so it's like $30, but you get professional quality boards. And they're, in America, there's like a billion board houses that you can go to, and they just do a big batch process, and they get you absolutely immaculate PCBs. So the design process has totally changed around here. It irks me because the design process that I learned involved iterating through a couple different technologies. Now it doesn't. You can do solderless breadboard. You can then come up with a surface mount design, and then $5 later and a week, you get a circuit board for that design, and you put it all together and you go, oh, I made 2 mistakes. And then you correct the mistakes. You spend $5 more, and more PCBs just vomit out of your mailbox. And you're like, oh, give me one of those, build it up, done. There's a professional project. Whereas in the past, you breadboard it, bring it over to a solder design, and I guess you could still do that, but it almost doesn't make any sense with $5 circuit boards. You bring it over to a solder design, vet out some of the issues, put the design together in CAD, then you would order $100 circuit boards. You get too many of them, vet out all the problems, you do that order again, and then you would get your professional circuit boards. But it's like you don't have to do that anymore. And actually, back in my day, we would do the Express PCB design, and that didn't have a solder mask on it. It was just exposed, but it was a decent etch, and that was like $50 for a couple boards. Yeah, but now you just fucking yeet it out to a board house. And like even the CAD, a lot of the CAD software, there's a pull-down menu. Send it to Seed Studio. It's like, done. It's amazing. The litigious great-grandson looking to cash in. I know, right? Well, the thing is, Fry's Electronics still existed when I came up with my emotes. I didn't copy them. I'm sorry. There's only so many emotes that you can do as an electronics channel, and I didn't want to do a resistor. So I did a chip, and chips have little arms all over them. And so that you know, I just did that in the smallest form I could, just so that it was very distinct. Like you know that they're my emotes. They have a design to them, and a commonality of design across the emotes. So that's one of those professionalism and art things that you know, jack of all trades, jack off of none, master of none. That's how that goes. Engineers often have to wear quite a few hats, and I have a few more hats in sort of the whole presentation, design, art, etc. So yeah, the times in school where we had to give presentations, I just fucking knocked that shit out of the park. I'm too good at that stuff. It's just when it comes to doing the math, that's where I fucking suck. All right, anyway, we're tracing out of these. So we've got all of the structures here. We know that this is up top. We haven't vetted out this area, this like top hat portion of it, but I'm just kind of looking at like, where's Q21? Where is that? So we're looking at the area of this circuit that comes off of awesome. Sorry, it's a Philly accent. Let's see. We're coming out of the ladder filter. Now the ladder filter, you guys aren't familiar. We've marked down where all the traces are in red and blue, just to be top and bottom. And so this image, we have kind of just like a key to it, and we know where everything's going. I could have also done this in color contrast. If I flip the contrast like way up, you can make those traces kind of pop out. And I think there were some efforts to make AI back in the early 2000s, make the mid 2000s, make AI do some of the like this work that we're doing right now. It would be very interesting to be able to throw it into something. That was, sorry, not mid, the 2010s, the mid 2010s, when AI was starting to become a little bit prevalent. Now it's just a mess. Language learning models were not around back then. But okay, so coming off of the transistor ladder filter, we've got two capacitors coming off of that. But this is the top of the stack. This is the output. So we have it going in two different directions here. It's coming from the junction between two transistors on the bases and going out this way. I'm looking at this one and this one. Well, that one and these two right here. And then up above, we go through small caps that have filters to ground and into the transconductance amplifier. Let's look up that transconductance amplifier. Let's just verify. That was, I think, another one that it was like Ben Gizmo or something. Somebody was familiar with this, but transconductance amplifier with the LM137 billion. So the LM137 billion is two of these. What are they for? Like, what does it mean? What is transconductance? Is that when you get like a particular segment of the LGBTQ to conduct your orchestra? I don't know what transconductance is. LM13700 series consists of two current-controlled, and then they use the word. Define the word. Let's just Google the word and see if we can get an answer here. Transconductance amplifier. Demystifying the operation of transconductance. Operational OTAs are often among the least understood analog components. All right, we're already off to a good start. Define the word with the word. That's what they're doing here too. They can't help it. These people don't know how to, they don't know how to handle transconductance curving. What does that even mean? Get ready to cringe. I'm sort of opposite-ish. I loved math so much. I would stay up late, obsessed to do all the work and problems in a math textbook. I'm dying of cringe right now. It's starting low and building up. That's the typical, that's the typical engineer mindset though. I hated the math. Hated it. I like the doing part. Culminated in a medal in college for 95% above. Damn, for 3 calculus classes. Then I had kids and became a mediocre dropout. Oh no. No, that's like the loving the math. The problem is that like the application of the math, like in the real world, it's not if you really want to be that like carved out for engineering, it would be a love of both math and spreadsheets. That's what would get you into the real world. But I'm an application kind of person. Mathematic analog of one curve or another. A mathematical analog to a curve. Huh. So why specifically this? OTAs are versatile building blocks. Yeah, OTA, I guess, is the transconductance amplifier. Building blocks that intrinsically offer wide bandwidth for many types of amplifiers. The OTA, or voltage-controlled current source, can be viewed as an ideal transistor. Dear God, I'm not reading this whole thing. I think the point of it is that it amplifies, but it follows a particular curve that would match up with, I guess, the 303's amplifying stage. But the transconductance part, I just don't understand the word. But so yeah, we trace power and ground into this thing, and we do believe that it is a transconductance amplifier. In which case, and this is the interesting part, the Germans, the acidlab.de folks, instead of following this as the output stage amplifier, they did something a little bit more akin to the schematic we found here. So this is actually the transconductance amplifier. And it's got capacitors on the in route. Very complex to explain, but very simple to get the concept once you get it. And it's probably impossible to explain to a streamer, I would have to assume. It's like, not only sometimes there's a language barrier and I have to like translate people's comments a little bit. Sometimes I translate just because I'm a document like editor. I just make things a little clearer and sometimes do that. So we've got language barrier, we have knowledge barrier, and we have just like the streamer barrier, which is that anything communicated to me is going to be read in whatever mood I'm in, which more than once a stream, I will get something so wrong, the mood of something that was typed or what the intention was. And like, some of you guys know to like pepper your language with stuff to help me out. But, or like when asking a question or making a snippy comment on something that I just said, there are like 2 6-second barriers between when your message shows up and when whatever I say is transmitted out. So there's all these delays and just it's a mess. It's wonderful that we can have this communication be fast enough that you guys can somehow sort of get like close to what I'm talking about and we can understand each other. But if we were having a conversation, it would be extremely awkward. There would be these huge pauses between stuff. Excel draw. That's okay. Is there a pictograph? I think the whole point is that as this thing gets different voltages, it'll amplify based on the way something else amplifies, or you can edit the curve of how it amplifies. And maybe that's just being used in an audio context to make it kind of work similarly to the 303. So all things considered, this should be an amplification stage, this sort of like polyp that sits on the side of the rest of this. And then we're coming out to 2 directions, and it's this signal right here. So 15 milliseconds, blah, 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 blah. That is our output signal from the ladder. I thought I'd see more of the adjustments in there, but... So instead of this here, we've got the amplifier. What's this? Maybe we can understand by reading this. Like an algorithm is to translating a code in the programming realm, each input is a particular output. This is where the place on the curve of your input yields a place on a different curve. So it has a curve, and then we're taking our inputs as a location on that curve. Is that sort of what we're getting at? And that would be the that would be the transconductance element. So that would mean the LM30 whatever should have like a curve, right? Each with differential push-pull output, the 2 amplifiers share common supplies, but otherwise operate independently. Linearizing diodes are provided at the inputs to reduce distortion and allow higher input levels. The result is a 10 dB signal-to-noise improvement over... They always get into the weeds in the descriptions of these things. Like when they're describing their component, they describe it to like the application engineer that has read every single one of their documents ever, right? They say, oh, this one has a slightly better linearization of blah, 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 blah. And I'm like, what are you talking about? Like, what does this thing do? What does it do? They're like, ours is better than the other ones because it actually does this very specific thing slightly different. And I'm like, yeah, but like, what? You haven't said what this thing does. What do I do with it? So, all right, so you know, signal in, signal out. I guess this thing follows what is it would be bias current? No. Bias current, ambient temperature. I don't know. And so it just, yeah, it's like a map of the inputs. A voltage to voltage converter. There you go. Yeah. Instead of just a straight line, it actually has a curve for volt per volt. screw that narrative, like the statement I just made. With this value is to blah, 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 blah. Oh, I see. Yeah, they're putting their best stats up there. And this would be sort of the typical usage, huh? No, this isn't typical. V and input. Okay. Voltage controlled amplifier. So this is essentially the VCA portion of it, but I think they're hitting one of those transconductance amplifiers as their amplification right here. So at the output of that one, it would be potentially our signal is then amplified and ready to go to the next stage. So the ins and outs on this thing are, oh, this is the abstract. Wait, let's get rid of this. That's confusing. Our inputs and outputs for the transconductance amplifier are like this. And so our plus and minus inputs should be pins 3 and 4 or 13 and 14. So these two right here, and they are mirrored. So what we essentially have is what we're dealing with here is a total lack of respect for the law. Okay, so we're across this capacitor. I'm going to draw it across this way because I don't have room. But we're essentially going from here and here. And then we have two capacitors. And then we have 2 resistors to ground. Do a dot on both of those. The resistor to ground is 1004, so it's 100K. And we don't know what the ceramic capacitors are. You can test them, but then the rest of the circuit also kind of influences them. And so the one that is on the near side goes to pin, oh god, 1, 2, 3, 4. So pin 4. Oh, and then that one has a capacitor to ground. So pin 4 is the one that goes here. P4. I'm doing a short notation for the chip, but I probably shouldn't. And then the other one goes to pin 3, like we predicted. This. And so pin 3 and 4. Three is positive. Oh, good. It's in the same orientation. That's always nice. Plus, minus, and then I do 2 little circles on the output, I guess. And then that goes to pin 5. And then we've got the buffer. My buffer's upstairs. She's sleeping by the door. Grasping what it does means power. And you can ponder with delight what you can do to make something function, especially for audio signal generator type of circuit. I don't know. Bias and then output. So let's just see what else is. So this is definitely what that is, an LM13700. This is another one of those censored devices. We've got our ladder filter coming in here. We have a capacitor on this. So this one's pin 1 going to a 1702, so a 1.7K to ground, and that would be the buffer. No, the bias input. So bias input, pin 1, and that goes to ground, and that's 1.7K. We're making good progress on this, actually. I don't know if I'll comprehensively reverse engineer the entire circuit, because that's a little bit, welcome to the Tedium Dome, where we're reverse engineering a circuit. I don't think that's entirely necessary. Pin 2, diode bias. Blah! diode BAW isn't going anywhere. So diode BAW doesn't do anything. Doot, and then we've got some kind of a wackadoodle thing going there on pin 1, 2, 3, 4, 5. Pin 5 does a thing. That's my new children's book. Pin 5 is output. And that goes to what I think is a transistor. Or sorry, I think is a coil. I don't know if that, I mean, it could easily be a capacitor, but it seems like it's a coil because it's in line with everything. I think it goes through both amplifiers then, because it seems to loop back down and around to the second one, which is, that's a lot of amplifiers. Sorry, I'm jumping around. It's the scroll wheel messes with me. But output also goes up here, where it's got, what the heck? So this is on the BIOS. No, the buffer. That's right, the buffer. And again, my buffer is upstairs. She's sleeping by the door. So output is going around, and it's going to the other one. It's very strange. Math chips are more different curve shapes of these, but expensive for some of those things. That's weird, yeah. The Tedium Dome was something I stole from the Harry Potter Rift Racks. Every time they played Quidditch, the guys were incensed with how boring it was. And so they showed the outside the stadium, and one of the guys, welcome to the Tedium Dome. And that stuck with me because it was hilarious. Okay, so we've got a much better idea of what's going on here. How far out do you think I need to go? I guess we need to define a little bit more of this stuff. If the transconductance amplifier isn't working, well, the problem is our signal dies like immediately into this thing. And there's some parts of the signal over here that we haven't really explored. This stuff here, like this stuff down here, these loose transistors. If they're all 3904s, which I guess I'll mark down in red. We'll do an eyedropper on this. Oops. Actually, you know what? It's probably in the history. Yeah, there it is. And then we drop down to the red layer. Go to pencil. Thin pencil does not help me out. 3904. Maybe parenthesis all? Because I don't see any PNPs. Hey, Cosmo Quest X, rating with a party of 10. We've been it's kind of a misc day. It's kind of a day where I'm not totally concentrating on stuff because I didn't sleep. And I did a bunch of crazy stuff today, and it's a super hot day out, so we're kind of hiding away, and we're sort of poking at our little circuits here, right? Staying indoors, staying under air conditioning, staying in the basement where all the cold air settles. This is the M303. The M303 is a modular, hence the M, synthesizer made by acidlabs.de, and they made the M303 very specifically to make a rack, a Euro rack equivalent of the TB303, which is a legendary acid house Roland synthesizer. It has a synthesizer, it has a filter, it has a sequencer. They took the sequencer out. Actually, I don't know if the TB303 has a sequencer in it. Anyway, whatever. The M303 is a modularized version of that. So the working components that make a 303 sound like a 303 are replicated on this board. Problem is, the IDC connector, typically used in Euro racks for power, it is insulation displacement connector. It's got these little like tapered pieces of metal that flat cable pushes down into and makes contact, right? Does it run Doom? It doesn't. It actually, one of the few things that can't run Doom, and most of the time when you see stuff run Doom, it is just a screen that has been taken over as like a screen. Like, you know that Doom running on a pregnancy test? That was just taking the output of a computer running Doom and translating it onto that tiny little screen. It wasn't a computer scientist got in and actually got the hardware to run Doom. Some, you know, most of the stuff when you see it running Doom is actually running Doom because computer scientists are freaks. But sometimes when you get something that's too good to be true, like my pregnancy test runs Doom, it's too good to be true. It's just, they're just using the screen. Yeah, if you guys haven't checked them out, CosmoQuest X is a series of streamers who does cool newsy stuff. Sorry, I'm saying that, it's cool space newsy stuff. I'm saying that like into this, like it's a microphone. I'm like, you know, it's really cool. Do the cool space stuff. Anyway. The pregnancy test was actually running Doom. No, we got to the bottom of that. It was not. It was not. It doesn't have that hardware. It wasn't running Doom, it was displaying Doom. That was the one that we looked into. This synthesizer, we took photos of the top and the bottom, we traced over all of the traces. So now we have this sort of working document that we can look through in order to figure out what is connected to where. Well, it turns out, because of the nature of this thing, because it is a 303, we have Roland's design files. And Roland, not making the 303 anymore, they do have all of these things just for you to look through. It's amazing, actually. You can come in here and you can build any of their hardware just through this kind of documentation. This is so that their techs can actually test and tune and fix problems with these things. You see, this one had no markings around the IDC connector. You could plug it in wrong. That's what my friend did. He plugged it in wrong. God forbid you would plug in something that's extremely easy to plug in wrong, especially as a musician and maybe a drunkard. But so this thing blowed up, and we actually got a PDF from Acid Labs. Somebody who was familiar with them, Ben Gizmo, was familiar with them. He sent me a PDF that actually had, and I lost the location of the link. I should have saved it onto my desktop or something. It was a simple guide to what happens when you plug power in wrong, and it had a couple of the chips that you replace in order to get this thing functioning again. And we replaced those chips. This thing still doesn't work. It's not outputting sound. So what I did is I reversed the connectors so that we could put the front PCB to the side. We can actually poke in on the signals here. And we found that the signal suddenly stops. This stupendous, superfluous, supplemental, shit-eating signal stops as soon as it gets supplied. I gotta stop doing that. Anyway, it stops at the voltage-controlled filter, the VCF. So we know that the VCF uses a particular schema. It is a transistor ladder filter. There's diode ladder filters, there's transistor ladder filters. They kind of work the same. I don't quite know how they work. It's just a way to filter a signal. Look, listen, I watched a Moritz Klein video where I believe he is how I refer to Moritz Klein. Correct me if I'm wrong. But he went through the circuit of a transistor ladder or a diode ladder. I think they're the same principle, and explained it really, really well. And then I watched it again, and I still don't know. It's math. It's some weird principle of math or something. I don't know what it's doing. I don't know how. I should know. My brain isn't as plastic as it used to be. Computer scientists are freaks. I suppose that's beyond geek for a tech perspective. Well, just calling people geeks is boring. You got to come up with other ways to call them freaks. Anyway, so I should know how these work. People know how these work. Transistor ladder is a fairly common thing. I need to know more related to the exact hardware so that I know when I'm poking around, stuff isn't happening. Well, stuff ain't happening the way it's supposed to happen. I need to know where to focus in on those elements of the circuit. I think I need a haircut too. But yeah, I need to be able to actually get in there and figure out what's going on. And so the best way to get that knowledge, especially when you don't know what's down here on the circuit, we don't have C's and R's and we don't have a schematic. So we're working a little bit more towards making a schematic. I wish we had like this, and I know this exists, files similar to this for the M303, because we have that internal PDF. We have that internal PDF where everything's been censored out except for the components that you're supposed to replace if specifically you plug it in wrong. The other thing that happened was I accidentally plugged in this thing wrong, because this has two headers like this, and you can flip it 180 degrees and still plug it in. Screw holes don't quite line up, but just that commonality, the symmetry. This thing has evil symmetry in the circuit, but that symmetry allowed me to blow it up in a new and unique way. So me being super Mr. Electronics expert, oh, Jesse will definitely be able to fucking fix this thing. You guys aren't supposed to know my first name. Anyway, oh, bother will definitely fix this thing because he's an electronics expert. And then I blow up more of it. It's embarrassing, and I need to get over this. So getting more of the schematic is a way for me to kind of get over this. Since we know that the oscillation and stuff is happening properly, we figured out where that wibbling signal gets into this thing right here, and then we see a bunch of capacitors with a bunch of what were little blocky circuit things just lined up next to each other. And that pretty much tells us that there is that type of filter. It's pretty crazy. Like, you see this, and what keys me off to these being transistors is that they've got this triangular set of vias. These triangular set of vias are how you would put a through-hole transistor into something. So this is our transistor ladder filter, and it's 3 stages of it. The other accoutrements are around here. This was a censored circuit. We replaced it, but I didn't know if we replaced it with the proper thing. I had my doubts. Now that we've gone through a little bit more of this part of the circuit, it's definitely looking like this is exactly what it was. It's an LM3046M. That's a very detailed explanation of what went sideways, almost like you've lost some sleep over it. Yes. Evil symmetry, cousin of mine says broken symmetry. Thanks for joining us at that moment, broken symmetry, because that's the best way to describe it. The symmetry of this thing is the downfall. It's what I messed up. Where's my light? Oh, it's on. It's just over there. Yeah, if it was 120 volts in these modular, these Eurorack synthesizers, I would have been in trouble. I would have been in big trouble. I actually had from China and I don't know how this cable ended up on my 3D printer, but I did all this work with my 3D printer, like revamped a whole bunch of stuff, and I plug it in. Everything's great. Everything works just great. Turn it off, and I go and I sit down at my desk in my shop, and then I notice that there's like a blue light. I'm like, what? What the hell? So look, nothing's going on. Oh, that's weird. I thought I saw a blue light. This is back when my 3D printer was to my back. It's weird. I thought I saw a blue light. Then I saw it again. Aha! I know something's going on. So I turn around and I sit there for like 10 minutes. And the backlight, the LCD backlight for the 3D printer would light up blue and then turn off. What the hell's going on there? Probe everything, look everything. You look at it, turn it on. It works just fine. Turn it off. Wait. Light on, light off. Why? Why is it doing that? What's going on? Traced it all the way back to the power. The active line, the phase that was coming in, was on ground. It was on the neutral. Phase was on neutral. What the hell? How did that happen? I didn't do this wrong. What's going on here? Why is my power switch turning off neutral to everything else? So it's turning off neutral, and then power was leaking to capacitors and stuff and charging them. And then they would discharge to ground, like case ground. So it was whatever was hitting case ground, I was getting powered up for a little bit. Turns out the NEMA cable, the typical computer style cable that is in everything, had neutral and ground switched. It was cable from China, cut it apart. The only way we were able to tell is, ohming it and everything. And then I cut it, and it at the very end of the cable, they must have flipped the two. So one side it was normal, the other side flipped. Kind of dangerous. It's kind of dangerous. You got to watch out for stuff like that. Would have been a sight for the power cables, thick as your leg, being powered up with 200 volts AC. Yeah, those are pretty crazy. Tech was sent home right away. The military contractor said he will never work here again. Jesus. Yeah, it was crazy. Right out of the box, this thing had neutral and line swapped. And it didn't show up anywhere because it's just a differential, right? It's just a differential. So if you plug it into most devices, you won't notice that. But because I had wired this thing myself, I had the phase come into the power switch and then out of the power switch. It's a 120 volt power switch. Not the best idea in the world, but whatever. It's the way you do stuff if you're working quickly. And so I wouldn't have noticed it if it weren't for that intermittent power that it would provide. Very strange times. All right, so I'm relatively confident about most of the stuff here. I know that the remainder, the parts that we haven't figured out yet, are the things down here below this little phallic tower of transistors. We know that this piece right here, it's hard to see what I'm highlighting. I'm highlighting the thing on the right next to the penis tower is the transconductance amplifier. So somehow the VCA portion of this, I think, is wrapped into, because on the Roland version, VCA is a separate section. That's this here. Although, does this look rather familiar? This looks rather familiar. Capacitor, resistor. Although those are two different values. They might have I don't know. It feels kind of like they shortcut some of it. Do they say what IC that is? It just says IC5, but we can look that up. So this is one of these weird things about schematics done by other people. We're looking for IC5. IC Wiener. Oh, these aren't labeled that way. Should that then label it next to the thing? These documents are wonderful. If you're ever looking to like build a synthesizer, opening up stuff like this Roland, what is it? Service manual. The service manuals are great. They'll give you all the logic and stuff like that you would need to fix it, and that helps give you like ideas of how you would want to structure your own. But that's where modular synthesizers came about, because when you build something like a synthesizer, you're like, ooh, I want something to create waves, I want something to filter them, I want something to amplify them, and then I want to do something special over here. And how you configure that can vary from synthesizer to synthesizer very easily, right? You're going to do things in slightly different ways. Well, why not take those modular components and make them into modules? And so you have a bunch of modules that do that stuff. And now you have this setup where you're kind of in your own little walled garden and you can't mess anything up. So if I plug this audio source into a controls voltage signal, it's not going to blow up. And it's not going to blow up my speakers. It'll just simply do things weird. And so that leads to a lot of creativity from modular synthesizer enthusiasts. Blah, blah, blah. Get a job. This is a weird section. I don't know if that's somewhere else. I thought the transconductance amplifier would do that. Because why would you throw a transconductance amplifier in an area that you would just have some kind of a transistor amplifier, which I assume is what's going on here. What the fuck? Well, maybe not. We're getting a differential from that, and then, oh, I see, we're applying it here. We're applying it here through a supermatched that's doing like, is that doing ringing? What is that doing? Capacitors, and then two resistors, and then we got that thing there. So as this is activated, we're putting stuff on this line. And then we're taking a fraction of that and we're putting it over. Weird. Yeah, it's yak, yak, yak. Get a job. It's from hackers. All of my stuff is derivative. And then the output is coming out of C14 there once it's amplified. Weird, weird. But instead, they're using a transconductance amplifier, which is sort of like what this thing is doing. All right, well, I got a lot more work to do on this thing to figure out what else is going on. But we've traced most of what we've been looking at. This would be that phallic ladder filter. I truncated it because I don't have room. So we know where our signal's coming from, and we lose it here. Why do we lose it there? Well, it's going through there, and it's going to a bunch of elements over here. I don't think this chip is dead. Oh, I haven't figured out where P3 goes yet. Hold on, pin 3. Let's look at pin 3 real quick. See, in this case, it goes down to a transistor and then to ground. Give it up, give it up, give it up. All right, pin 3 goes over to 2.2K. So let's pull that. All right, let's get this over here. Get this out of the way. Get this in the way. I didn't want to do a full reverse engineer with you guys. I'd rather do it kind of on my own. But some people said it would be interesting to see, and you guys have been pretty positive about me doing this. That was way too close to that line. But again, I don't do four-way junctions, so seeing this here, I know that that's not connected because there is no dot. And I don't do four ways. So when you cross over, you can either do a little jump, you can do just the two lines over top of one another, or you can do two lines and a dot. I don't do, unless I'm backed into a corner, I will not do four-way junctions. Instead, I'll split them up like this, where I just move it up or down on the line. And then that way you avoid the oops, you avoid the oops, I forgot to put a dot there situation. 3904. We can transconduct like that. I don't even know what that means. We've been over this. It's so confusing. SMD transistor pinout. Now you would think, and I've been through this rant before. I've done this rant quite a bit. You would think that a device that is based on 3 layers of silicon, where they're layered one on top of the other, very simple, and you have one of them as a collector, one of them as an emitter, and one of them as a base. You would think that that would go into a device that looks like a transistor. It is the same shape. It is a block that has a dot and a dot and a pin, a pin, and a pin. You would think that it would be collector, base, emitter. But you would be an asshole and you would be wrong. No. Why would you think that? You have wrong think. You did this incorrectly. Because the way these are arranged, and I think this is to more easily get a resistor in it, it is with the collector on one side, the emitter on another, and the base remains. And I think that's so that your emitter and your base can have a resistor across it. You can hold this up. Did I do that right? Is that the right one? Collector, emitter, yeah. Yes. So that's the way these are arranged. So looking at that thing over there, I'm actually going to draw a collector, emitter, base on it because I'm going to get it wrong so much. And unless it's right under my nose, I will not have the wherewithal to get it right. So just in that one, where's that? Where did I write that? That's on the wrong layer. Whatever. Yeah, so C. I can do it inside. E. C. B. C. B. E. Unless they're, if they're NPNs or if they're specialty ones. But I'm just going to assume that they're like this. Although that one goes to ground. That's collector to ground. That may not be the case with that one. We'll see. I mean, the circuit structures are going to become more evident as I go. Seb. All right, maybe that'll clarify things for me just a little bit as we go through, because this is a fairly busy part of the circuit. I mean, the stuff's going crazy. Bonk. It's so confusing. Oh yeah, and the schematic symbol for it is this. Least common is multiple collector or else emitter leads. I think it's just because when you're putting something in like a switch thing, you'll do a resistor like this to the collector. And then you'll switch whatever. So this'll hold it. So that if you have like a microcontroller switching it, that way you just put a resistor out here. That's like really easy. I don't know. Anyway, over here. We are looking at this portion right here. We've got the resistor that's in the upper right-hand corner, and that one goes... Does it have anything to do with the other transistor there? We've got a couple transistors here, actually. Oh boy, this is complicated. So that 2.2 goes into a collector, as well as both collectors, actually. It's going into two collectors. So with that going into two collectors, how does that relate to our circuit? That goes into one collector there. Yeah, that's different. That's like trims and stuff like that. Yeah. Okay, starting to get it a little bit more. That only goes into one transistor on this one. Why would it go into two on the other one? The base of the other one goes into the... Oh, that's an NPN. Or sorry, PNP. So NPN and PNP have the arrow going into different locations. And I've been yelled at on YouTube comments about doing that. So one of these might be PNP. It does definitely go into the collector of that one. These would be the ones that are internal to this thing. There's some noise around that where I've been taking notes and stuff, but it goes into there, and then the emitter comes out on this pin and goes out to here. Oy, this is getting a little complicated. So are these PNPs? Let's make that the collector. That appears to be the same way. 2.2 into the collector. Yeah, it's unarguable that this goes into two different locations. So that is a difference in the circuit. That's a pretty big difference. It's pin 3 going out to a 2.2K, which is exactly what we've got here. So that's what this pin 3 is, the mixing of the two emitters of the internally matched ones. And that goes through a 2.2K. It's the same resistor, but then it only goes to Q11 in this circuit, but then in the circuit that we actually have in our hands, it goes to two different locations. And one of those is a shared pin. Actually goes through a lot of stuff. Collector. Is that 2.2K going to... that 2.2K might be going to a power lead. That may be this right here. 2.2, but that 2.2 to power goes somewhere else. So there's nothing else that it goes to here. On pin 3, double check pin 3, hold on. Yeah, pin, oh, it's not, wait, no, it's not pin 3. No, that is pin 3. Pin 3. This is pin 3 right here, this junction, right? This three-way junction right here, pin 3. Oh, the print is quote-unquote done. Let's check on that real quick. The print is supposedly done. Let's check our 3D printer here. You guys can, I can move the camera down, but still will be difficult to see. A weird feeling I'm not going to see a benchy in there. It's hard for me to show you guys what's going on. Got a check mark that says the print is totally cool and awesome, and there it is. We have a benchy though. No, there's nothing on the plate. And then there's a removed benchy sitting on the plastic down there. Whew, and a nice heady heady gulp of plastic smell. There's where I scratched the stuff before, but the same thing's happening. It keeps breaking off of the plate midway through the print. It's happened 3 times now. Back into smell jail. Oh. Printing time, 2 hours. Okay, 30 minutes, whatever. Okay, so yeah, I'll have to break that off of my plastic stuff and then figure out how I'm going to get it to not do that. Yeah, it printed about 2 hours. No inspection tag required on the extinguisher. Oh, jeez, come on, man. Don't do that. Don't do the safety stuff to me. That's the wrong button. Yeah, so, all right, something's failing on the print. I don't know what I can do. Print prison is smart, but don't forget the gun. Depends on how into technology you are. Yeah. If my printer makes weird noises, I shoot it. Printer PSU causing too much heat inside the chamber. No, heat is good. Heat is good for resin prints. No, it's not sticking to the platen. And I think maybe what's going on is that when it gets to a certain point, it gets to like here, there's so much more surface area on the plastic than there is on the metal, and so this will peel away. Because I get so much surface area. So I think maybe what I need is like a couple supports on the outside of this, just to kind of make it let go. I don't know. Which I guess would be putting supports anywhere below that. So like, how much of this do I actually get when I do? I think I'm getting like there. I think maybe like here is where it becomes too stuck to the bottom than the top. It's weird that I wouldn't be able to remove that though. Yeah, it's just I constantly get that. Like, make sure to wear goggles. Make sure you're do this, do that, do that. And it's like, deal with yourself. I don't need your safety comments. Smelly liquid and light go in, pretty prints come out. Well, I have one Benchy that actually printed properly. Only the one. Only the one. I gotta check to see if that tube is on the print. I think it is. But like if I put supports here, maybe it'll hold on to it a little better. Just do like that. I don't know. I'll have to figure this out later. A hollow hull. There are auto supports, but the auto supports make a hash of it. And I did do a Benchy with auto supports, and it printed just fine. But auto supports, auto supports, auto supports. Hello, I am Otto. I'm here to support. This is what it does for auto supports. It makes a crazy mess. They come off pretty clean, but it's still kind of a mess. I don't know what the hell it's trying to do with all this. But it also puts the print up like this, and then all this structure down here is like, yeah, it's an ocean encounter with Cthulhu. So, I don't know. I could have it make an island. Add support to all islands. Uh, oh, it's island. It's looking for islands, like as in like a little piece that would come out. I don't know if I need to like do this on my own. Just add a bunch of little pincers to it to kind of hold it down as it goes through. I don't know. I'll have to play with it. It's just the more it fails like that, the worse my what is it, F stuff? What the hell is that stuff called? FEP. The more this messes up, the worse my FEP becomes. My FEP. So I don't know what to do. I'm gonna Control Z the supports because I wanted it. The other one I printed like you just saw. This one I wanted to print just like this. But I guess the tearaway steel magnet sheet, whatever it is, it's not sticky enough. I bet you if I printed directly onto the like laser pattern that was there before, that would really stick. But it would also carry that laser print pattern, so you'd want to have it up on supports for that. Yeah, like hollowing you can do, but I don't know if that's gonna really. Drain holes. Wait, pro, and pro. Object is a hole, on, off. Hollowing 3D. No, I don't know. Look, I think I'm finishing early today. We're gonna finish stream early because we got a little bit of progress done on that schematic, and so I can take some of the knowledge of what we figured out and revise maybe, or just go through it a little bit more, like actually go through the circuit while it's powered up, given what we figured out, right? Pretty near a phobia with eyewear. Look, we'll be fine. We'll all be fine. We'll take a look at this circuit a little closer in the future. If I can come up with some other good idea of what to do on stream, we'll do that. I'm still having trouble with this printer. It's giving me a lot of, I don't know how to describe it. It's like anger and anxiety at the same time. I'll get over myself. The Wera driver set. Yeah, I've got the set of Weras that I use on everything, and then I've got a ton of other. The iFixit screwdriver is sort of the be all. Got any electrical controls type projects? I have all kinds of stuff burning right now, and one of them burning a hole through me. But we'll figure out what we're going to do tomorrow. You know, that's up to me. It's up to me and whatever we have going on. Julian and Dave were supposed to come in, but we had a scheduling conflict. I'm actually really busy aside from Friday, so it's unfortunately. And then also I'd have to clean for them. I'd have to clean up everything, and it's just there's stuff everywhere. Maybe we do a cleaning stream. I don't know, but Julian and Dave, we're gonna get them in here, and they'll do synthesizer-y stuff. So that'll definitely happen in the near future. I need to cut out early. My dog needs to go outside. We'll blame her. I think most of it is iFixit is open it up, and Wera is I wasn't asking. These are fantastic. You do yourself a favor and get a set of Weras because they last really long. They take a little bit of abuse, but they're just very comfortable screwdrivers. And I've used them as just about everything other than a screwdriver as well. But these will also get you into those Torx bits that don't what is it, the WIAs? I don't know much about those. Wera screwdrivers will get you into security Torx without looking like you've gotten into security Torx. You just choose whichever screwdriver has the size where it goes to the side of the little tab that's supposed to make it a security Torx. Goes to the side of the tab, and it just grips and undoes the whole thing. It's my favorite thing to show people, and I barely get to do it anymore because we're not taking apart as many consumer products anymore. We took apart everything I have in relation to gaming, so now you know I don't have that content anymore. But all the security Torx on those things were easily circumvented using just a flathead screwdriver. It was amazing. And you know you don't need a Wera, but typically I'll be able to find a Wera that fits it of the sizes of the standard kit of screwdrivers. that leaves us with next time. So I am going to cut out early today. We'll figure out what we're doing for tomorrow. Hopefully I have enough stuff that we can do like a long stream tomorrow. Here's the end card. This contains my Twitter as well as my Discord. Discord kind of taking a fast track towards being an shitified product these days, but we're still on it. We're still on it. We're still using it. Twitter doing the same. For some reason, we're still on it and we're still using it. If that last straw breaks the camel's back, finally, I'll think about moving over to other platforms. But for now, we've staked out our claim on both Discord and Twitter. I don't have any other social media because I'm not going to totally inundate you guys with bother 24 hours a day. I'm going to go take my puppy for a walk and then die because it's 1,000 degrees out. And then we'll get back here tomorrow. In the meantime, I'll be on Discord. You can catch me over there. I'm starting to lose my voice. I'll talk to you guys all later. I have no idea what the Matrix is. There's a weird way to cap off your stream is to just say that. But I was asked. That wasn't just completely out